The night sky has always been our window into the infinite, a canvas where distant lights tell stories of worlds beyond our reach. But on July 1st, 2025, astronomers at the Atlas telescope in Chile captured something that would challenge everything we thought we knew about visitors from the void. An object, designated 3I Atlas, racing through our solar system at impossible speeds, carrying chemistry that defies explanation, and exhibiting behaviour that reads like a cosmic middle finger to the laws of physics. This isn't your typical comet story. This is about an interstellar wanderer that's rewriting the rules as it hurtles toward the sun, and the terrifying possibilities of what happens when something from beyond our neighbourhood decides to get up close and personal with the star that sustains all life on Earth. If this mystery has captured your imagination the way it has mine, don't let go. Hit that like button and subscribe, because we're diving deep into scenarios that will keep you staring at the ceiling tonight, wondering if tomorrow might be the day everything changes. Drop a comment telling me where you're watching from, what time it is in your world, and whether you think we're prepared for what's coming, because the truth demands nothing less than complete transparency. Let me paint you a picture of 3I Atlas that will haunt your dreams. This object arrived from interstellar space moving at roughly 58 kilometers per second. That's fast enough to cross the entire continental United States in about 2 minutes. It's following a hyperbolic trajectory, meaning it's not bound to our sun's gravity. It came from somewhere else, and after its brief visit, it will disappear forever into the cosmic dark. But here's where things get genuinely unsettling. As 3I Atlas approaches our star, it's not behaving like any comet we've ever studied. Most comets are basically dirty snowballs that start melting and creating beautiful tails that always point away from the sun, pushed by solar wind and radiation pressure. It's basic physics that's been consistent for every comet observed in human history. 3I Atlas is different. Spectroscopic analysis from the James Webb Space Telescope reveals a carbon dioxide to water ratio that's off the charts. Most comets are water-dominated, but this visitor is spewing carbon dioxide at levels that suggest it formed in conditions unlike anything in our solar system. Even more disturbing, it began outgassing water vapour when it was still 3.5 astronomical units from the Sun, way out near Jupiter's orbit where solar heating should be minimal. The size estimates keep changing as we get better looks at this thing. Early observations suggested it might be anywhere from a few hundred meters to several kilometers across. More recent data indicates it could be as large as 10 to 20 kilometers in diameter. That's not just a chunk of ice anymore, that's a mountain-sized object carrying unknown chemistry and exhibiting unexplained behavior. Now here's the part that should make your skin crawl. Recent observations have detected what appears to be a jet of material pointing toward the sun, not away from it, toward it. This violates every principle of comet physics we've established over centuries of observation. It's like watching a river flow uphill, or a ball roll up a slope on its own. The implications start small and grow exponentially. If this jet is real, if material from 3I Atlas is being directed sunward, then we're not dealing with a passive chunk of ice following predictable physics. We're dealing with something that's actively interacting with our solar environment in ways we don't understand. Let me break down what we know about our sun's vulnerability, because understanding the target is crucial to grasping the potential catastrophe. Our star isn't the stable, benign ball of light it appears to be. It's a roiling mass of plasma held together by gravity and regulated by magnetic fields that are in constant flux. Solar flares, coronal mass ejections, and magnetic reconnection events are happening continuously, releasing energy equivalent to billions of nuclear weapons. The Sun operates on an 11-year cycle of activity, oscillating between solar minimum and solar maximum. We're currently approaching solar maximum in cycle 25, which means solar activity is ramping up just as 3I Atlas makes its closest approach. The timing couldn't be worse. Here's the nightmare scenario that keeps solar physicists awake at night. The Sun is a nonlinear system, meaning small inputs can sometimes produce enormous outputs. It's like a controlled burn in a forest that suddenly becomes a wildfire when conditions align perfectly. If 3I Atlas is injecting charged particles or exotic material into the solar wind, and if the Sun is already primed for a major coronal mass ejection, that injection could be the trigger that releases stored magnetic energy on a scale we've never witnessed. A Carrington-level event today would be catastrophic. In 1859, when the last major geomagnetic storm hit Earth, our technology consisted of telegraph systems. Some operators reported receiving electric shocks, and auroras were visible as far south as the Caribbean. If a similar event occurred now, it could knock out power grids across entire continents for months, disable satellites that provide GPS navigation and communication, and cause trillions of dollars in damage to our interconnected technological civilization. But 3i Atlas represents a wild card that our worst-case models don't account for. Every disaster simulation assumes natural solar variability. None of them consider the possibility of an external trigger, especially one carrying unknown chemistry from another star system. The object will reach perihelion, its closest approach to the Sun, on October 29, 2025. That's just weeks away as I record this. At that point, it will be approximately 1.36 astronomical units from our star, somewhere between the orbits of Earth and Mars. While that might sound safe, distance becomes irrelevant if 3i Atlas triggers a solar event that sends charged particles racing toward Earth at millions of miles per hour. What makes this scenario even more terrifying is the information blackout surrounding detailed observations. While amateur astronomers and public observatories have tracked 3i Atlas since its discovery, there's a conspicuous absence of detailed data from military space surveillance networks. These systems are far more sensitive than civilian telescopes and would absolutely be tracking an anomalous object approaching our Sun. The fact that no classified observations have leaked suggests either there's nothing unusual to report, or there's something so unusual that it's being kept under the tightest possible security. The chemistry alone should be setting off alarm bells. The extreme carbon dioxide dominance suggests 3i Atlas either formed in conditions radically different from our solar system, or it's been processed by forces we don't understand during its interstellar journey. High-energy cosmic radiation could have altered its composition over millions of years, creating isotopes and compounds that don't exist naturally in our local environment. If this object is carrying exotic isotopes or radioactive materials concentrated through unknown processes, its outgassing near the Sun could introduce particles into the solar wind that affect how coronal mass ejections propagate. We simply don't know how the Sun's magnetic field would respond to contamination from materials that originated light years away under completely different stellar conditions. The trajectory analysis reveals another disturbing detail. 3i Atlas is following a path that brings it uncomfortably close to optimal solar interaction distance. It's not a sun grazer that will plunge into the solar atmosphere and be destroyed. Instead, it's maintaining just enough distance to survive while maximizing its exposure to solar heating and magnetic field interactions. That's either an extraordinary coincidence or evidence of something more deliberate. As we count down to perihelion, observatories worldwide are mobilizing unprecedented monitoring efforts. The James Webb Space Telescope, Hubble, and major ground-based facilities are dedicating precious observation time to track every aspect of 3i Atlas's behavior. But even with our most advanced instruments, we're essentially flying blind because we've never encountered anything like this before. The absence of precedent means we can't reliably predict what will happen when 3i Atlas reaches its closest approach to the Sun. Will it fragment under thermal stress? Will its outgassing intensify to the point where it creates a substantial particle cloud in the inner solar system? Will that mysterious sunward jet become more pronounced as solar heating peaks? Most unsettling of all, will the Sun respond to this visitor in ways our models can't anticipate? Solar physics is incredibly complex, involving magnetohydrodynamics, plasma instabilities, and energy transport mechanisms that challenge our most sophisticated computer simulations. Adding an unknown variable like 3i Atlas to that equation pushes us into uncharted territory where even our best scientists are reduced to educated guessing. The stakes couldn't be higher. Our civilization has become utterly dependent on technology that's vulnerable to space weather. Power grids, communication networks, GPS navigation, financial systems, internet infrastructure, all of it could be crippled by a severe geomagnetic storm. We're more capable than any previous generation, but we're also more fragile, relying on interconnected systems that can fail catastrophically when stressed beyond their design limits. What we're witnessing with 3i Atlas might be a preview of challenges we'll face more frequently as our detection capabilities improve and we discover that interstellar space is far more populated than we assumed. This visitor might be just the first of many, each carrying its own mysteries and potential dangers from star systems we can barely imagine. The countdown to October 29th has begun, and with each passing day, 3I Atlas draws closer to its appointment with our Sun. Whether that appointment results in spectacular scientific discovery or civilizational catastrophe remains to be seen. The deeper we dig into 3I Atlas, the more we uncover details that should terrify anyone who understands the delicate balance keeping our technological civilization intact. This isn't just about a comet anymore. This is about an object that's systematically violating every assumption we've made about how interstellar visitors should behave. Let's start with the timing, because timing in cosmic events is everything. 3I Atlas will reach perihelion during a period when our Sun is approaching solar maximum, the peak of its 11-year activity cycle. Solar maximum brings increased sunspot activity, more frequent solar flares, and a higher probability of massive coronal mass ejections. It's like having a visitor arrive just as your house is most likely to catch fire. The object's chemical signature becomes more disturbing the closer we look. That extreme carbon dioxide to water ratio isn't just unusual, it's unprecedented. Every natural comet we've studied shows the opposite pattern, with water ice dominating the composition. This reversal suggests 3I Atlas either formed under conditions so alien they don't exist anywhere in our solar system, or it's been fundamentally altered by processes we don't understand. Consider what this means for solar interaction. When 3I Atlas begins its most intensive outgassing near perihelion, it won't be releasing the familiar mix of water vapor and dust that characterizes normal comets. Instead, it will be injecting massive quantities of carbon dioxide and potentially exotic compounds directly into the solar wind stream. We have no models for how the Sun's magnetic field responds to this type of contamination because we've never seen it before. The size estimates keep growing as our observations improve, and that growth should concern everyone paying attention. Early calculations suggested 3I Atlas might be a few kilometers across, manageable for a comet. Recent analysis indicates it could be 15 to 20 kilometers in diameter, making it larger than many asteroids that have caused mass extinction events on Earth. A 20-kilometer object outgassing at the rates we're observing represents an enormous amount of material being ejected into space. But here's where the physics gets truly frightening. The solar wind isn't empty space. It's a supersonic stream of charged particles flowing outward from the Sun at roughly 400 kilometers per second. When 3I Atlas dumps its exotic chemistry into this stream, those particles don't just disappear. They become part of the solar wind, carried throughout the inner solar system, potentially reaching Earth within days of their release. The magnetic field implications are staggering. Earth's magnetosphere, the magnetic bubble that protects us from solar radiation, is designed to handle normal solar wind conditions. It's not equipped to deal with contaminated solar wind carrying unknown isotopes and exotic chemical compounds. If 3I Atlas introduces particles that interact differently with magnetic fields, it could destabilize the magnetosphere in ways that allow dangerous radiation to reach Earth's surface. Recent monitoring has detected something even more ominous. The mysterious sunward jet isn't constant. It appears to pulse, activating and deactivating in patterns that suggest some kind of internal regulation, rather than passive outgassing driven by solar heating. Normal comets don't have on-off switches for their emissions. They respond predictably to temperature changes as they approach and recede from the Sun. This pulsing behavior raises questions that venture into territory most scientists won't discuss publicly. If the jet is regulated, what's doing the regulating? If it's not purely thermal, what's driving it? The possibilities range from exotic physics we don't understand to scenarios that challenge our fundamental assumptions about what travels between the stars. Let's examine the trajectory more carefully, because the path 3I Atlas is following reveals details that should make us deeply uncomfortable. The object isn't just randomly tumbling through our solar system. Its approach angle and timing bring it to perihelion at a distance that maximizes solar interaction while minimizing the risk of destruction. It's threading the needle between being too close to survive and too far to have significant impact. That precision suggests either extraordinary luck or something more deliberate. Random objects ejected from other star systems shouldn't arrive with such optimal geometry unless there are far more of them than we've assumed, making coincidental precision statistically inevitable. But we've only detected 3 confirmed interstellar visitors in human history, making coincidence a weak explanation. The outgassing timeline adds another layer of mystery. 3I Atlas began releasing water vapor when it was still 3.5 astronomical units from the Sun farther out than Mars. At that distance, solar heating should be insufficient to drive significant sublimation of water ice. Yet instruments detected clear hydroxyl emissions, the signature of water molecules breaking apart under radiation. Something was heating the object's interior before the sun's energy should have penetrated its surface. Internal heating mechanisms in comets typically involve radioactive decay or chemical reactions triggered by cosmic ray bombardment. But the intensity of heating required to drive out gassing at such distances suggests either an unusually high concentration of radioactive isotopes or energy sources we haven't identified. Both possibilities are unsettling when dealing with an object from an unknown stellar environment. The data gaps in our observations create additional cause for concern. While civilian observatories have tracked 3I Atlas since its discovery, there's been conspicuous silence from military space surveillance networks. These classified systems monitor everything in space with sensitivity far exceeding public telescopes. They would absolutely be tracking an anomalous object approaching our sun, yet no information has emerged from these sources. This silence could indicate either that classified observations show nothing unusual, supporting natural explanations for 3I Atlas's behavior, or that they've detected something so significant it's been compartmentalized at the highest levels of security classification. The absence of leaks suggests either ironclad operational security or genuine uncertainty about how to interpret what's being observed. The technological vulnerability of our civilization cannot be overstated. A severe geomagnetic storm could disable satellite navigation systems that guide everything from commercial aircraft to precision agriculture. Financial markets rely on GPS timestamps for high-frequency trading. Power grid synchronization depends on satellite signals. Internet traffic routing uses space-based infrastructure. The cascading failures from losing these systems simultaneously could collapse modern commerce and communication within hours. Emergency planners have modelled Carrington-level events, but their scenarios assume natural solar activity following predictable patterns. None of the disaster simulations account for external triggers that could amplify or accelerate solar storms. 3I Atlas represents an unknown variable that could turn a manageable space weather event into a civilizational crisis. The biological implications deserve serious consideration as well. If 3I Atlas is carrying exotic isotopes or organic compounds from its origin system, its outgassing near the Sun could introduce materials into the inner solar system that have never interacted with Earth's biosphere. Most of this material would be sterilized by solar radiation or burned up in our atmosphere, but even trace amounts reaching Earth's surface could have unpredictable consequences. Panspermia, the hypothesis that life spreads between star systems via comets and asteroids, remains scientifically plausible. If 3I Atlas harbours dormant microorganisms that survived the interstellar journey, their release near the Sun could seed the inner solar system with alien biology. The probability is extremely low, but the stakes are high enough to warrant consideration. The countdown continues relentlessly toward October 29th, 2025. Each day brings 3I Atlas roughly 1.4 million kilometers closer to its appointment with our Sun. Solar heating is intensifying, outgassing rates are increasing, the mysterious sunward jet is becoming more active, and we're running out of time to understand what we're really dealing with. What happens next could define whether 3I Atlas becomes a footnote in astronomical history, or the event that forces us to completely reconsider our place in a universe far stranger and more dangerous than we ever imagined. The object is approaching the point of no return, where solar gravity and heating will drive it toward behaviors we can only guess at. But 3I Atlas isn't the only cosmic anomaly demanding our attention. As we'll see, the universe seems determined to challenge our understanding on multiple fronts simultaneously, creating a perfect storm of uncertainty just when we need clarity the most. The cosmic chess game being played around us involves pieces we're only beginning to recognize, and 3I Atlas might be just one move in a strategy that spans millennia. While we've been focused on this singular visitor from beyond, other phenomena across the universe have been exhibiting behaviors that challenge our most fundamental assumptions about reality itself. In October 2025, the James Webb Space Telescope delivered observations that sent shockwaves through the astrophysics community. Black holes, those gravitational monsters that should take hundreds of millions of years to grow to massive sizes, were discovered already fully formed when the universe was barely 400 million years old. These weren't small stellar remnants. These were supermassive black holes containing billions of solar masses, sitting at the centres of galaxies that had barely had time to coalesce. The timeline makes no sense according to our models. There simply wasn't enough time for stars to form, live their lives, die in supernovae, and leave behind black holes that then merged and grew to such enormous scales. Either black holes can form through pathways we never considered, or they grow far faster than our equations predict, or something seeded the early universe with these gravitational anchors. This discovery matters because it reveals the same pattern we're seeing with 3I Atlas, objects appearing where and when they shouldn't, behaving in ways that force us to question whether our understanding of cosmic processes is fundamentally incomplete. The universe seems determined to remind us that our models are approximations, not absolute truths. Meanwhile, closer to home, particle physics experiments have been uncovering their own set of anomalies. The muon magnetic moment measurements at Fermilab continue to deviate from standard model predictions, with increasing statistical significance. These subatomic particles, heavier cousins of electrons, are exhibiting magnetic properties that suggest the existence of forces or particles we haven't discovered yet. The precision required for these measurements is extraordinary. Scientists are detecting discrepancies that amount to parts per million, yet the consistency of these deviations across multiple experiments suggests we're glimpsing physics beyond our current theories. If the fundamental forces governing matter at the smallest scales contain surprises, why should we assume macroscopic objects like comets will conform to our expectations? The connection isn't immediately obvious, but it's philosophically crucial. When nature refuses to follow our rules at the quantum level, it's reasonable to expect surprises at astronomical scales as well. 3I Atlas might be revealing gaps in our understanding of interstellar objects similar to how muon experiments are revealing gaps in particle physics. Artificial intelligence systems designed to predict stellar events have achieved remarkable success in forecasting supernovae before they occur. Machine learning algorithms trained on vast datasets of stellar observations can now identify the subtle precursor signatures that indicate a star is about to explode. This gives astronomers advance warning to point their instruments at the right patch of sky and capture these spectacular events in unprecedented detail. But here's the limitation that should concern us. AI systems are only as good as their training data. They excel at recognizing patterns they've seen before, but they can struggle with genuine outliers, events that fall outside their experience. 3I Atlas represents exactly this kind of outlier. Its behavior doesn't match the limited sample of interstellar objects we've observed, making it difficult for any predictive system to forecast what it might do next. The danger of over-reliance on algorithmic predictions becomes apparent when dealing with unprecedented phenomena. If we trust AI assessments that classify 3I Atlas as a normal comet, because that's the closest match in its training data, we might miss warning signs that human intuition and scientific skepticism would catch. Even our own planet has been exhibiting signs of instability that correlate suspiciously with increased cosmic activity. Earth's magnetic field, generated by the motion of molten iron in our planet's core, has been fluctuating more dramatically than usual. The South Atlantic anomaly, a region where our magnetic shield is particularly weak, has been growing and intensifying. The magnetic poles themselves are drifting at accelerating rates. The North Magnetic Pole has been racing towards Siberia at roughly 50 kilometers per year, much faster than historical averages. Some researchers speculate we might be approaching a geomagnetic reversal, a complete flip of our planet's magnetic field that occurs every few 100,000 years on average. While most geophysicists attribute these changes to internal Earth processes, there are speculative connections to external factors. Variations in cosmic ray flux, influenced by solar activity and galactic dynamics, might affect cloud formation and climate patterns in ways that feed back into geomagnetic field behavior through complex atmospheric and oceanic coupling mechanisms. Could the approach of 3I Atlas, with its unusual chemistry and outgassing patterns, contribute to disturbances in the solar wind that propagate all the way to Earth's magnetosphere? The chain of causality would be subtle, but not impossible. Enhanced solar wind pressure from comet-contaminated particle streams could compress our magnetosphere, potentially affecting the delicate balance of currents and fields that maintain magnetic stability. The timing of these multiple anomalies creates an uncomfortable pattern: black holes forming too early in cosmic history, fundamental particles behaving unexpectedly, artificial intelligence reaching new capabilities while potentially developing blind spots to unprecedented events. Earth's magnetic field showing increasing instability, and now an interstellar visitor exhibiting behavior that challenges our understanding of cometary physics. Each anomaly individually might be explainable through natural processes we don't fully understand, but collectively they paint a picture of a universe in flux, where the rules we thought were constant are revealed to be more flexible than we assumed. This flexibility becomes genuinely concerning when it involves objects and forces that could directly impact human civilization. The solar cycle timing adds another layer of complexity to our situation. Solar cycle 25, which began around 2019, is expected to peak sometime in 2025, exactly when 3I Atlas reaches perihelion. Solar maximum brings increased sunspot activity, more frequent flares, and higher probability of major coronal mass ejections. The convergence of peak solar activity with the closest approach of an anomalous interstellar object creates conditions we've never had to navigate before. Solar physicists have sophisticated models for predicting space weather based on observable solar phenomena. They can track sunspot development, measure magnetic field configurations, and forecast the likelihood of eruptions with reasonable accuracy. But these models assume normal solar wind conditions and standard electromagnetic environments around the Sun. The introduction of exotic particles from 3I Atlas could alter the fundamental assumptions underlying space weather prediction. If the object's outgassing changes the density, composition, or electromagnetic properties of the solar wind, even slightly, it could affect how magnetic energy builds up and releases in the solar corona. Small changes in initial conditions can lead to dramatically different outcomes in complex nonlinear systems like stellar plasma dynamics. Emergency management agencies have spent considerable resources developing response plans for severe space weather events. They've modeled power grid vulnerabilities, identified critical infrastructure that needs protection, and established protocols for coordinating recovery efforts after a major geomagnetic storm. But these preparations assume threats that follow historical patterns and natural solar variability. The 3I Atlas scenario represents an unknown variable that existing emergency plans don't account for. If the object triggers enhanced solar activity through mechanisms we don't understand, the resulting space weather could exceed the parameters that emergency planners have prepared for. We could face a crisis that's simultaneously predictable in its general effects, but unprecedented in its specific characteristics. The information warfare aspect of this situation deserves serious consideration. In an era where public trust in institutions is fragile, how authorities communicate about 3I Atlas could be as important as the object's actual behavior. If worst-case scenarios begin materializing, the public response will depend heavily on whether people believe they're receiving accurate information from credible sources. The challenge is communicating genuine uncertainty without creating panic. Scientists honestly don't know what will happen when 3I Atlas reaches perihelion because we've never observed anything like it before. This uncertainty is normal and appropriate given the available data, but it's difficult to communicate to public audiences who expect definitive answers to questions about potential threats. The risk of both overreaction and underreaction creates a delicate balance for science communicators and emergency managers. Overemphasizing worst-case scenarios could trigger unnecessary panic and economic disruption. Underemphasizing legitimate concerns could leave populations unprepared for events that, while unlikely, carry enormous consequences if they occur. As we approach the final weeks before perihelion, the observational data continues accumulating. Every telescope capable of tracking 3I Atlas is gathering measurements of its brightening, outgassing rates, spectral evolution, and trajectory refinements. This wealth of data will either support natural explanations for the object's behavior or reveal additional anomalies that push us further into uncharted territory. The scientific process is working exactly as it should. Hypotheses are being tested against observations. Models are being refined or discarded based on evidence. Peer review is ensuring that conclusions are supported by data rather than speculation. But the process takes time, and time is the one resource we're rapidly running out of as October 29th approaches. The broader implications extend far beyond this single object. 3I Atlas might be the harbinger of a new era in astronomy, where interstellar visitors are common rather than rare, each one potentially carrying surprises from stellar environments we can barely imagine. Our detection capabilities are improving rapidly, and future sky surveys will likely discover dozens or hundreds of such objects over the coming decades. If 3I Atlas proves to be genuinely anomalous, it forces us to reconsider our assumptions about what travels between the stars. The space between stellar systems might be far more populated and dynamic than we've assumed, filled with objects that challenge our categories and defy our expectations. Each new visitor could bring its own mysteries and potential risks. The technological implications are equally profound. Our increasingly sophisticated artificial intelligence systems and automated detection networks are powerful tools for monitoring cosmic threats, but they're not infallible. The combination of human intuition, scientific skepticism, and machine learning capabilities provides our best defense against surprises from the universe. But defense implies that we're under attack, and that might not be the right framework for understanding our situation. 3. iAtlas might not be a threat in any intentional sense. It could simply be a natural object following physical laws in ways we don't yet comprehend, revealing aspects of cosmic evolution and stellar system dynamics that expand our knowledge rather than threaten our existence. The distinction between threat and opportunity often depends on preparation and response rather than the phenomenon itself. A solar storm can be catastrophic if it catches us unprepared, or it can be a manageable challenge if we have adequate warning and protective measures in place. The same principle applies to exotic interstellar visitors and their potential effects on our solar system. As the countdown to perihelion continues, we find ourselves in the uncomfortable position of being spectators to events we can observe but not control. 3. iAtlas will do whatever it's going to do regardless of our understanding or preferences. Our role is to watch, learn, and adapt to whatever the universe decides to teach us through this remarkable visitor from the void between stars. The lessons we learn from 3 iAtlas will inform how we approach future interstellar objects and prepare for cosmic scenarios we haven't yet imagined. Whether those lessons involve updating our models of cometary physics or developing new frameworks for understanding artificial objects in space, the knowledge we gain will be invaluable for navigating an increasingly complex and surprising universe. The timeline becomes even more disturbing when we examine what's happening behind closed doors. While public observatories share their findings through standard academic channels, military space surveillance networks have maintained conspicuous silence about their observations of 3 iAtlas. These classified systems possess sensitivity far exceeding civilian telescopes and would absolutely be tracking every detail of this object's approach. The absence of leaks from defense agencies suggests either their data supports mundane explanations, or they've detected something significant enough to warrant the highest levels of security classification. Given the potential implications for national infrastructure, the latter possibility cannot be dismissed. Power grids, communication networks, and satellite systems represent strategic assets that any responsible government would want to protect from space weather threats. But there's another angle to consider that ventures into territory most analysts won't discuss publicly. What if 3 iAtlas isn't entirely natural? What if we're dealing with something that was designed, engineered, or directed by intelligence that isn't human? I know how that sounds. I know the immediate reaction is to dismiss such possibilities as science fiction fantasy. But consider the evidence objectively. An interstellar object arrives with chemistry unlike anything in our solar system. It exhibits controlled outgassing patterns that pulse rather than responding predictably to solar heating. It maintains a trajectory that optimizes solar interaction, while minimizing destruction risk. And it's doing all of this during a period when our sun is approaching maximum activity. The precision required for such timing and positioning suggests either extraordinary coincidence or something more deliberate. Random debris ejected from other star systems shouldn't arrive with such optimal geometry unless interstellar space contains far more objects than we've detected, making coincidental precision statistically inevitable. But we've only confirmed 3 interstellar visitors in human history. The first, 1I Oumuamua, accelerated mysteriously as it left our solar system. The second, 2I/Borisov, behaved more like a conventional comet, but still showed unusual chemical signatures. Now 3 iAtlas exhibits the most extreme anomalies yet observed. The pattern suggests either we're incredibly unlucky in our sampling, or interstellar objects are more diverse and potentially artificial than our models account for. The engineering hypothesis becomes more plausible when we consider the energy requirements for interstellar travel. Any civilization capable of sending probes between star systems would need to solve problems we're only beginning to understand. How do you power a machine for millions of years in the void? How do you protect delicate components from cosmic radiation? How do you ensure the probe activates at the right time and place to accomplish its mission? Solar energy collection provides an obvious solution to the power problem. A probe designed to harvest energy from stars could remain dormant during interstellar cruise and activate when approaching a suitable target. The controlled outgassing we're observing could be exhaust from internal systems powering up after eons of hibernation. The sunward jet takes on sinister implications in this scenario. Instead of violating comet physics, it becomes evidence of directed propulsion or attitude control. A machine approaching the sun might need to adjust its trajectory precisely to avoid destruction, while maximizing energy collection or data gathering. The pulsing patterns could represent thruster firings rather than thermal outgassing cycles. This interpretation explains several anomalies simultaneously. The unusual chemistry could result from artificial construction materials rather than natural ice formation. The early water detection could indicate internal systems beginning to function. The optimal approach geometry could reflect deliberate navigation rather than gravitational chance. If 3I Atlas is artificial, its proximity to the Sun during solar maximum isn't coincidental, it's strategic. A probe designed to study stellar behavior would want to observe our star during its most active phase. The timing suggests either remarkable luck or intelligence sophisticated enough to predict solar cycles across interstellar distances and centuries of travel time. The implications cascade outward like ripples in a pond. If one artificial probe has reached our solar system, there are likely others. A civilization capable of interstellar exploration wouldn't send a single scout. They would deploy networks of observers, data collectors, and possibly more specialized devices we haven't identified. Some might already be positioned throughout our solar system, dormant and undetected until their programming activates them. Others might be approaching from directions we haven't monitored as carefully. The asteroid belt, Kuiper belt, and Oort cloud could harbour visitors we've mistaken for natural debris, because we weren't looking for signs of artificial origin. The search parameters would need to change fundamentally. Instead of cataloguing rocks and ice balls, we'd need to identify objects exhibiting behaviours inconsistent with passive gravitational motion. Subtle course corrections, unusual thermal signatures, electromagnetic emissions, or chemical compositions that don't match formation models. The technological signature of 3I Atlas might be subtle enough to escape casual observation, while remaining detectable to instruments specifically designed to look for artificial characteristics. Its carbon dioxide dominance could result from exotic propulsion chemistry. Its pulsing outgassing could be waste heat, from internal systems cycling on and off. The military implications explain the information blackouts surrounding detailed observations. If defense agencies have detected technological signatures in 3I Atlas's behavior, that information would be classified at the highest levels. Confirming artificial origin for an interstellar object would have profound consequences for national security planning, space policy, and international relations. How do you prepare for visitors whose capabilities and intentions are unknown? How do you protect critical infrastructure from technologies that might be centuries or millennia ahead of our own? How do you coordinate global responses to phenomena that transcend national boundaries and earthly politics? The psychological preparation becomes as important as the technical response. Humanity has spent its entire history believing we're alone in the universe, or at least isolated from other intelligences by the vast distances between stars. The confirmation that we're being visited, observed, or studied would shatter fundamental assumptions about our place in the cosmic order. Religious, philosophical, and cultural frameworks would require radical revision. If we're not unique, if intelligence is common enough that other civilizations send probes to monitor emerging species, then every aspect of human self-understanding needs reconsideration. Are we subjects in someone else's experiment? Are we being evaluated according to criteria we don't understand? The probe scenario also raises uncomfortable questions about consent and autonomy. If 3I Atlas is collecting data about our solar system, our planet, or our civilization, we weren't asked for permission. We weren't informed about the observation. We're being studied by entities whose existence we only recently began to suspect. The power imbalance is staggering. A civilization capable of interstellar travel possesses technological capabilities that make them effectively omnipotent from our perspective. They could influence our climate, trigger natural disasters, or interfere with our technology in ways we might never detect or understand. But perhaps the most disturbing possibility is that they're not interested in us at all. 3. Atlas might be focused entirely on the Sun, studying stellar behaviour for purposes that have nothing to do with the small rocky planet orbiting in the habitable zone. We could be irrelevant observers watching something that will affect us profoundly while remaining oblivious to our existence. The solar interaction becomes the critical factor, regardless of whether 3I Atlas is natural or artificial. If the object triggers enhanced solar activity through any mechanism, natural or engineered, the consequences for Earth remain the same. Power grids fail, satellites are damaged, communication networks collapse, and modern civilization faces its greatest test since the advent of electronic technology. The countdown to October 29th continues with mounting urgency, as new data streams in from observatories worldwide. Each measurement brings us closer to understanding what we're really dealing with, but the answers might be more disturbing than the questions they replace. Recent spectroscopic analysis has revealed additional anomalies that push 3I Atlas even further outside the boundaries of natural explanation. Isotope ratios in the outgassing material don't match any known formation environment in our galaxy. The chemical signatures suggest exposure to radiation fields in stellar conditions that don't exist around normal stars. Either this object formed in an environment so exotic we have no analogue for it, or it was constructed using materials gathered from multiple stellar systems and processed through techniques we can't imagine. Both explanations challenge our understanding of what's possible in the universe we inhabit. The magnetic field measurements add another layer of complexity. 3I Atlas appears to be generating electromagnetic signatures inconsistent with passive outgassing from heated ice. The patterns suggest organized electrical activity, possibly from internal power systems or electromagnetic field manipulation for propulsion or navigation. If confirmed, these measurements would provide the strongest evidence yet that we're dealing with technology rather than geology. Natural objects don't generate coherent electromagnetic fields unless they're highly magnetic asteroids, and the spectroscopy rules out metallic composition for 3I Atlas. The observational window is narrowing as the object approaches perihelion and becomes increasingly difficult to observe against the sun's glare. Soon, we'll lose direct visual contact for several weeks, while 3I Atlas passes behind our star from Earth's perspective. When it emerges on the other side, it will either confirm our worst fears or provide the reassurance we desperately need. But reassurance might be harder to achieve than catastrophe. If 3I Atlas passes through perihelion without triggering obvious solar events, we'll still be left with an object exhibiting inexplicable behaviour and carrying implications that extend far beyond this single encounter. The questions it raises about interstellar visitors, artificial probes, and our cosmic isolation won't disappear just because immediate disaster is avoided. The universe has delivered 3I Atlas to our doorstep, at a moment when our civilization is uniquely vulnerable to space weather events and uniquely capable of detecting anomalous behaviour in visiting objects. Whether this timing represents coincidence, cosmic irony, or deliberate scheduling by intelligences we're only beginning to recognise remains the most important question facing humanity. The answer might fundamentally alter our understanding of who we are and where we stand in a universe that's proving to be far stranger, more populated, and more dangerous than we ever dared to imagine. October the 29th approaches with the inevitability of an eclipse, carrying possibilities that could reshape human history or confirm that some mysteries are too vast for our current comprehension. The biological contamination scenario represents perhaps the most insidious threat posed by 3I Atlas. While power grid failures and satellite disruptions would be immediately obvious, biological contamination could unfold over months or years before we recognize what's happening. The object's exotic chemistry suggests it formed in stellar environments radically different from our own, potentially incorporating organic compounds or even dormant microorganisms that survive the interstellar journey. Panspermia, the hypothesis that life spreads between star systems via comets and asteroids, remains scientifically plausible. Laboratory experiments have demonstrated that certain extremophile organisms can survive exposure to space conditions for extended periods. Tardigrades, microscopic creatures resembling eight-legged bears, can enter cryptobiotic states where their metabolism essentially stops, allowing them to survive radiation, vacuum, and temperature extremes that would kill most life forms. If 3I Atlas harbours similar organisms adapted to even harsher conditions, its outgassing near the Sun could release them into the inner solar system. The solar wind would carry these biological agents throughout our cosmic neighbourhood, and some fraction might eventually reach Earth's orbit. While most would be destroyed by atmospheric entry, meteorite impacts prove that some materials can survive the journey to Earth's surface. The introduction of alien biochemistry into Earth's biosphere could trigger ecological cascades we're utterly unprepared to handle. These organisms might fill empty niches without disrupting existing ecosystems, or they could prove invasive, outcompeting native species and fundamentally altering the balance of life on our planet. The European colonization of the Americas provides a sobering historical parallel, where introduced diseases devastated populations with no prior exposure. But alien pathogens represent an even more extreme scenario. Any microorganisms that evolved in completely different stellar environments would possess biochemical pathways unlike anything in Earth's evolutionary history. Our immune systems, which evolved to recognize and combat terrestrial threats, might be completely ineffective against alien biology operating on fundamentally different principles. The detection timeline for biological contamination adds to the nightmare. Unlike electromagnetic effects that manifest immediately, biological impacts could remain invisible for months or years while alien organisms establish themselves in Earth's environment. By the time we noticed unusual ecological changes, the contamination could be irreversible and globally distributed. Agricultural systems represent particularly vulnerable targets. If alien microorganisms interfered with plant growth or soil chemistry, food production could be compromised on a planetary scale. The green revolution that feeds our current population depends on carefully balanced agricultural ecosystems that could be disrupted by the introduction of organisms operating according to different biological rules. Marine ecosystems face similar risks. Ocean currents would distribute biological contaminants globally within years of their introduction. Phytoplankton, the microscopic organisms that form the base of marine food webs and produce much of Earth's oxygen, could be particularly susceptible to alien biological interference. The isotopic contamination angle presents another layer of concern. 3I Atlas's extreme chemistry suggests it contains isotopes rare or absent in our solar system. As the object outgasses, these exotic isotopes enter the solar wind and potentially reach Earth's atmosphere. While most would be filtered out by natural processes, even trace amounts could accumulate in biological systems over time. Radioactive isotopes from interstellar sources could have different decay patterns and biological effects than terrestrial radioactivity. Plants and animals that evolved with Earth's background radiation levels might not be adapted to handle exotic isotopes with unfamiliar decay chains and energy signatures. Subtle increases in mutation rates could accelerate evolutionary pressures in unpredictable directions. The atmospheric chemistry implications deserve serious consideration as well. 3I Atlas is releasing massive quantities of carbon dioxide along with other compounds we're still identifying. While this material will be dispersed throughout the inner solar system, some fraction will eventually interact with Earth's atmosphere through complex pathways involving the solar wind and magnetosphere. Even tiny changes in atmospheric composition could trigger climate effects that cascade through weather patterns, ocean circulation, and seasonal cycles. Earth's climate system is finely balanced, and introducing exotic chemistry from another star system could push it toward tipping points we haven't identified or prepared for. The psychological warfare aspect of biological contamination cannot be ignored. The mere possibility that alien organisms might be infiltrating Earth's biosphere could trigger social responses as damaging as any actual contamination. Public health systems would face unprecedented challenges distinguishing between real threats and mass hysteria. Historical pandemics demonstrate how quickly fear can spread through interconnected populations. The COVID-19 experience showed both our capabilities and limitations in responding to novel biological threats. An alien contamination scenario would strain those systems beyond their design parameters while introducing uncertainties that traditional epidemiology cannot address. The research infrastructure needed to detect and analyze alien biology doesn't exist in its current form. Our laboratories and diagnostic equipment are optimized for terrestrial biochemistry. Identifying organisms that operate on different principles would require developing entirely new analytical techniques and safety protocols. International coordination becomes critical but politically complicated. Biological contamination wouldn't respect national boundaries, yet the response would require unprecedented cooperation between countries that struggle to coordinate on far simpler issues. The World Health Organization and similar institutions would need emergency authorities they don't currently possess. The economic disruption from biological contamination could exceed that of electromagnetic effects. Agricultural losses, public health costs, research expenditures, and trade restrictions could trigger global recession lasting years or decades. Insurance systems aren't designed to handle alien contamination events, leaving individuals and institutions vulnerable to catastrophic losses. The long-term evolutionary implications become mind-bending when considered seriously. If Earth's biosphere incorporates alien genetic material or biochemical pathways, the trajectory of life on our planet would be permanently altered. Evolution would continue, but according to hybrid principles combining terrestrial and extraterrestrial influences. Future generations might inhabit a world where the distinction between Earth life and alien life becomes meaningless, where hybrid organisms dominate ecosystems, and where humanity itself might be genetically influenced by interstellar contamination. The philosophical implications challenge our most basic assumptions about identity, origin, and destiny. But biological contamination might not be accidental. If 3I Atlas is artificial, its exotic chemistry could be intentional, designed to introduce specific changes to planetary biospheres. Terraforming or ecosystem modification could be the probe's primary mission, with solar interaction being merely the delivery mechanism. The timeline for such changes would be measured in decades or centuries rather than days or weeks. We might not recognize the full scope of biological modification until it's irreversibly established. By then, Earth's biosphere could be following a development path chosen by intelligences we never directly encountered. The detection challenge becomes even more complex when we consider that beneficial contamination might be indistinguishable from harmful contamination in its early stages. Alien organisms that ultimately improve Earth's ecosystems or enhance human health would initially appear as threatening as those that cause damage. Our response might inadvertently prevent positive changes we're not prepared to recognize. The quantum effects of biological contamination extend beyond immediate health and ecological concerns. If alien organisms operate using quantum biological processes more sophisticated than those found in terrestrial life, they could introduce new capabilities into Earth's biosphere. Enhanced photosynthesis, quantum coherence in neural systems, or exotic biochemical pathways could fundamentally upgrade biological performance on our planet. But these same quantum effects could be weaponized, either intentionally or accidentally. Organisms that interfere with terrestrial quantum biology could disrupt cellular processes in ways we can't predict or counter. The intersection of alien biochemistry with Earth's quantum biological systems represents uncharted territory, where our models provide no guidance. The technological contamination scenario deserves consideration alongside biological threats. If 3I Atlas contains nanotechnology, or self-replicating systems, its outgassing could release artificial organisms into the solar wind. These technological entities might be designed to interact with planetary environments, gathering data, modifying conditions, or preparing for larger interventions. Distinguishing between biological and technological contamination could prove impossible with current analytical methods. Sufficiently advanced nanotechnology might be indistinguishable from exotic biology, operating according to principles that blur the line between living systems and engineered devices. The sterilization protocols needed to contain such contamination don't exist. Earth's biosphere is an open system constantly exchanging materials with space through atmospheric interactions, meteor impacts, and solar wind coupling. Complete isolation from potential contamination would require technological capabilities far beyond our current achievements. The monitoring systems needed to detect alien contamination are still theoretical. We would need global sensor networks capable of identifying biochemical signatures that don't match terrestrial patterns, along with analytical capabilities that can distinguish between natural variation and alien influence. The cost and complexity of such systems would require international cooperation on unprecedented scales. The treatment options for alien biological contamination range from limited to non-existent. Our medical and agricultural systems are optimized for terrestrial biochemistry. Developing countermeasures for alien organisms would require understanding their biochemical pathways, life cycles, and vulnerabilities. This research could take decades while contamination spreads unchecked. But perhaps the most disturbing aspect of biological contamination is its potential irreversibility. Electromagnetic effects from solar storms are temporary. Infrastructure can be repaired, satellites can be replaced, power grids can be restored. But biological changes to Earth's ecosystems could be permanent, fundamentally altering the trajectory of life on our planet for millions of years. The decision trees for responding to suspected biological contamination involve impossible choices. Overreaction could cause more damage than the contamination itself, disrupting food systems and triggering social collapse. Underreaction could allow alien organisms to establish themselves beyond any possibility of containment. The early warning systems for biological contamination are essentially non-existent. Unlike electromagnetic effects that manifest immediately, biological impacts could remain undetected until they're irreversibly established. We might not realize we're contaminated until the changes are global and permanent. The ethical implications of biological contamination force us to confront fundamental questions about planetary stewardship and species survival. Do we have the right to quarantine Earth against potential improvements to our biosphere? Do we have the responsibility to protect terrestrial life from alien influence, even if that influence might be beneficial? The children born after biological contamination would inherit a world we can't imagine, where the rules of life have been rewritten by cosmic visitors we barely understand. Their biology, psychology, and capabilities might be enhanced or compromised by alien influences we never detected or controlled. As 3I Atlas approaches its closest encounter with our Sun, the biological contamination scenario remains the most difficult to prepare for and the most impossible to undo. The object's exotic chemistry virtually guarantees that its outgassing will introduce materials into our solar system that have never interacted with Earth's biosphere. Whether those materials prove beneficial, harmful, or simply strange may not be apparent for years or decades. By then, the choices will have been made for us by forces beyond our control, and humanity will face whatever consequences emerge from our first confirmed encounter with chemistry that originated among alien stars. The countdown continues toward October 29th, carrying possibilities that extend far beyond electromagnetic disruption or infrastructure damage. 3I Atlas might be rewriting the biological future of Earth with every kilogram of exotic material it releases into space, creating changes that won't be fully understood until long after the object has disappeared back into the interstellar void. But biological contamination represents just one thread in a tapestry of interconnected threats that 3I Atlas could unleash. The gravitational anomalies detected around the object suggest additional mechanisms of influence that could reshape our understanding of physics itself, forcing us to confront the possibility that reality operates according to principles we're only beginning to glimpse. The gravitational signature of 3I Atlas has been generating quiet concern among physicists who specialize in exotic matter theories. Standard gravitational models predict how objects of various masses should behave as they move through space, but 3I Atlas appears to be generating gravitational effects slightly stronger than its estimated mass should produce. The discrepancy is small, barely detectable with current instruments, but it's consistent across multiple observational platforms. Either our mass estimates for the object are significantly low, or it contains materials with gravitational properties unlike anything in our experience. Both possibilities open doors to physics that could revolutionize our understanding of matter and energy. Exotic matter theories propose substances with negative mass, or unusual gravitational properties that could exist under extreme conditions. If 3I Atlas formed in environments involving neutron-star collisions, black hole interactions, or other high-energy astrophysical events, it might contain materials with gravitational signatures we've never encountered in terrestrial or solar system samples. The implications extend beyond academic physics. Materials with exotic gravitational properties could enable technologies we currently consider impossible. Propulsion systems that manipulate gravity directly, energy generation through gravitational interactions, or even space-time manipulation for faster-than-light travel could become feasible with access to such materials. But exotic matter could also pose unprecedented dangers. Gravitational anomalies could affect planetary orbits, tidal forces, or even the stability of atomic structures if the effects are strong enough. The introduction of materials with unusual gravitational properties into our solar system could have consequences that unfold over astronomical timescales. The dark matter connection adds another layer of complexity to gravitational anomalies. Current cosmological models suggest that approximately 85% of all matter in the universe consists of dark matter that interacts gravitationally but not electromagnetically. We've never directly detected dark matter particles, but their gravitational effects shape galaxy formation and cosmic structure. If 3I Atlas contains concentrated dark matter or materials that interact unusually with dark matter, it could provide our first direct samples of this mysterious substance. The scientific value would be incalculable. potentially resolving fundamental questions about cosmic composition and structure that have puzzled astronomers for decades. But dark matter interactions could also trigger effects we're unprepared to handle. If concentrated dark matter destabilizes in the intense gravitational environment near the Sun, it could release energy through mechanisms we don't understand. The particle physics of dark matter remains largely theoretical, leaving enormous uncertainty about how it might behave under extreme conditions. The time dilation effects represent another exotic possibility that sounds like science fiction, but follows naturally from Einstein's general relativity. If 3I Atlas contains materials dense enough to create significant gravitational fields, it could generate measurable time dilation effects in its immediate vicinity. Objects near intense gravitational sources experience time more slowly relative to observers in weaker gravitational fields. If 3I Atlas generates stronger gravity than its apparent mass suggests, sensitive atomic clocks on nearby spacecraft or satellites might detect temporal anomalies that reveal exotic matter properties. The discovery of gravitational time dilation around 3I Atlas would confirm that we're dealing with physics beyond our current experience. It would also raise disturbing questions about how such effects might influence Earth's timekeeping systems, GPS satellites, and other technologies that depend on precise temporal synchronization. The quantum gravitational effects become relevant when considering materials that might bridge the gap between general relativity and quantum mechanics. Current physics treats gravity and quantum effects as separate phenomena that haven't been successfully unified into a single theoretical framework. If 3I Atlas contains materials where quantum and gravitational effects become comparable in strength, it could provide experimental access to physics that currently exists only in theoretical speculation. Such materials might exhibit behaviors that violate classical assumptions about causality, energy conservation, or the fundamental nature of spacetime itself. The technological applications of quantum gravitational materials could enable capabilities that seem magical by current standards. Instantaneous communication across arbitrary distances, energy extraction from vacuum fluctuations, or manipulation of probability itself could become feasible with access to appropriate materials and understanding of their properties. But quantum gravitational effects could also threaten the stability of reality as we understand it. If materials from 3I Atlas interact with the quantum vacuum in unexpected ways, they could trigger cascade effects that propagate throughout spacetime, potentially altering the fundamental constants that govern physics throughout our local region of the universe. The information storage hypothesis suggests that 3I Atlas might be carrying data encoded in its gravitational signature. Advanced civilizations might use gravitational waves or exotic matter configurations to store and transmit information across interstellar distances, creating a communication method that's essentially undetectable to civilizations without appropriate technology. If the gravitational anomalies around 3I Atlas represent encoded information rather than simply exotic matter properties, we might be receiving messages we don't know how to decode. The data could contain everything from scientific knowledge to warnings about cosmic threats, but accessing it would require gravitational wave detectors and analysis techniques we're only beginning to develop. The cosmic string connection represents perhaps the most exotic possibility for explaining 3I Atlas's gravitational behavior. Cosmic strings are hypothetical one-dimensional defects in spacetime that could have formed during the early universe's phase transitions. These structures would have enormous linear mass density but negligible volume, creating gravitational effects unlike any normal matter. If 3I Atlas contains fragments of cosmic strings or materials that formed in their vicinity, it would explain both the gravitational anomalies and the exotic chemistry we've observed. Cosmic string interactions could have processed normal matter into configurations that don't exist anywhere else in the observable universe. The detection of cosmic string materials would revolutionize cosmology and fundamental physics simultaneously. It would provide direct evidence for theories about the universe's earliest moments, while demonstrating that exotic space-time structures can survive and travel between star systems. But cosmic strings also represent potential sources of catastrophic instability. If the materials in 3I Atlas retain connections to cosmic string networks, their behavior near the Sun could trigger effects that propagate along string structures spanning galactic distances. The consequences could extend far beyond our solar system. The wormhole hypothesis ventures into territory that most physicists consider highly speculative, but the gravitational anomalies around 3I Atlas don't match any conventional explanation. If the object contains materials or structures that connect to other regions of spacetime, it could explain both the exotic matter signatures and the unusual chemistry we've observed. Wormhole connections could allow materials from completely different cosmic environments to coexist within a single object. Chemistry from regions near black holes, neutron stars, or even other universes could be integrated into what appears to be a conventional comet, creating the impossible combinations of elements and isotopes we've detected. If 3I Atlas contains active wormhole connections, its approach to the Sun could destabilize these spacetime links, potentially opening pathways between our solar system and regions of space or time we're not prepared to encounter. The influx of materials, energy, or information through such connections could overwhelm our ability to respond or adapt. The gravitational wave emissions from 3I Atlas remain below current detection thresholds, but they could intensify as the object approaches perihelion and its exotic matter properties interact more strongly with the Sun's gravitational field. The LIGO and Virgo gravitational wave detectors might be able to measure space-time distortions that reveal the true nature of the object's composition. Gravitational waves carry information about their sources encoded in frequency patterns and amplitude variations. If 3I Atlas generates detectable gravitational radiation, the signal characteristics could reveal whether we're dealing with exotic matter, cosmic strings, micro black holes, or other phenomena that exist at the intersection of general relativity and quantum mechanics. The measurement of gravitational waves from 3 Atlas would provide the first direct observational evidence for exotic matter properties in an interstellar object. It would also demonstrate that such materials can survive interstellar travel and remain stable over cosmic timescales, suggesting that the universe contains populations of exotic objects we've never suspected. The solar interaction effects become even more complex when gravitational anomalies are considered alongside electromagnetic and chemical influences. If 3I Atlas possesses exotic gravitational properties, its proximity to the Sun could trigger space-time distortions that affect solar dynamics through mechanisms not included in standard stellar models. The Sun's magnetic field generation depends on the precise motion of plasma in its interior, driven by convection patterns that could be influenced by external gravitational perturbations. If 3I Atlas creates local space-time curvature effects, they might alter convection dynamics in ways that change magnetic field configuration and solar activity levels. Such effects would be subtle and delayed, potentially not manifesting until weeks or months after 3I Atlas passes perihelion. But they could influence solar behavior for years, creating long-term space weather patterns that don't match historical cycles or current prediction models. The planetary orbital effects represent a longer-term concern that could unfold over years or decades. If 3I Atlas generates gravitational fields stronger than conventional matter would produce, its passage through the inner solar system could subtly alter planetary orbits through gravitational perturbations we haven't calculated. The changes would be tiny, measured in fractions of kilometers over orbital periods, but they would accumulate over time and could eventually destabilize the precise gravitational balance that maintains stable planetary motion. The effects might not be detectable for decades, but they could gradually push the solar system toward configurations that threaten Earth's climate stability. The asteroid belt and comet populations could be particularly susceptible to gravitational perturbations from exotic matter. Objects with marginal orbital stability could be nudged toward Earth-crossing trajectories, increasing the long-term impact risk from conventional solar system debris whose orbits were altered by 3I Atlas's passage. As October 29th approaches, the gravitational mysteries surrounding 3I Atlas continue deepening rather than resolving. Each new measurement reveals additional anomalies that push the object further outside the boundaries of conventional physics, suggesting that our first detailed encounter with an interstellar visitor might also be our first encounter with materials and phenomena that exist at the very edges of theoretical possibility. The implications cascade through every aspect of physics, astronomy, and cosmology, forcing us to confront the possibility that the universe operates according to principles we're only beginning to glimpse. Whether those principles prove beneficial or catastrophic for human civilization may depend on forces and intelligences so far beyond our current understanding that we're reduced to the role of observers watching events we cannot predict or control. The countdown to perihelion continues with mounting urgency as gravitational anomalies join electromagnetic disturbances, chemical contamination, and biological threats in a constellation of possibilities that could reshape reality itself. 3I Atlas carries more than exotic matter and alien chemistry. It carries the potential to reveal that everything we thought we knew about the universe was merely the first chapter in a story whose scope and implications we're only beginning to comprehend. The electromagnetic cascade represents the most immediate and measurable threat posed by 3I Atlas as it approaches its solar rendezvous. While gravitational anomalies and biological contamination operate on timescales we can barely comprehend, electromagnetic disruption would manifest within hours of any significant solar interaction, creating a domino effect of technological failures that could cripple modern civilization. Our planet's technological nervous system depends entirely on electromagnetic stability. Power grids synchronize across continental distances using precisely timed signals. GPS satellites provide positioning data accurate to within meters. Communication networks route information through electromagnetic pathways that span the globe. Internet infrastructure relies on fiber optic cables and wireless transmissions that operate within narrow frequency bands. All of this delicate orchestration could be shattered by electromagnetic pulses from enhanced solar activity. The Carrington event of 1859 provides a historical benchmark for electromagnetic catastrophe, but that comparison understates the current danger by several orders of magnitude. When the last great geomagnetic storm struck Earth, our most sophisticated technology consisted of telegraph systems. Operators reported receiving electric shocks from their equipment, and aurora displays were visible as far south as the Caribbean. The total economic impact was measured in thousands of dollars and affected primarily communication networks. A Carrington-scale event today would cause damage measured in trillions of dollars and affect every aspect of modern life. The National Academy of Sciences estimates that a severe geomagnetic storm could leave 130 million Americans without power for months, disable GPS navigation worldwide, disrupt financial markets that depend on satellite timing signals, and damage hundreds of satellites in Earth orbit. But these estimates assume natural solar variability following predictable patterns. They don't account for enhanced solar activity triggered by external factors like the exotic chemistry and electromagnetic signatures of 3I Atlas. If the object's approach to the Sun amplifies or accelerates coronal mass ejection formation, the resulting electromagnetic pulse could exceed the parameters that emergency planners have prepared for. The satellite constellation that enables modern communication faces particular vulnerability to enhanced space weather. Over 5,000 active satellites currently orbit Earth, providing everything from weather monitoring to military reconnaissance. These spacecraft operate in the Van Allen radiation belts, regions where Earth's magnetic field traps charged particles from the solar wind. During geomagnetic storms, these radiation levels spike dramatically. Satellites are designed with radiation shielding appropriate for normal space weather conditions, but they're not equipped to handle the prolonged high-energy particle bombardment that could result from 3I Atlas triggering enhanced solar activity. Electronic components degrade rapidly under intense radiation, causing satellites to malfunction or fail completely. The replacement cost for damaged satellites could reach hundreds of billions of dollars, and manufacturing new spacecraft takes years. The GPS constellation represents a critical single point of failure for technological civilization. These 31 satellites provide positioning and timing data that modern society depends on for everything from navigation to financial transactions. High-frequency trading systems use GPS timestamps to synchronize trades across global markets. Power grid controllers rely on GPS timing to maintain electrical synchronization across vast networks. Emergency services use GPS coordinates to dispatch first responders. If geomagnetic storms disable GPS satellites, the cascading failures would affect virtually every technological system in existence. Aircraft would lose navigation capability, forcing widespread flight cancellations. Shipping containers would become untraceable, disrupting global supply chains. ATM networks would fail as banks lose synchronization capability. Even cellular phone networks would degrade as base stations lose timing references. The power grid vulnerability extends beyond simple equipment damage to include systemic cascade failures that could take months or years to fully repair. Electrical transformers, the massive devices that step voltage up and down for efficient power transmission, are particularly susceptible to geomagnetic-induced currents. These transformers are custom-built for specific installations, and manufacturing replacements can take 12 to 18 months. The loss of electrical power creates exponential complications across all other technological systems. Data centers require continuous power to maintain internet services. Cellular towers need electricity to remain operational. Water treatment plants depend on electric pumps to maintain pressure. Food distribution networks rely on refrigerated transport that requires fuel and electricity. The interconnected nature of these systems means that prolonged power outages trigger societal breakdown. The internet infrastructure faces multi-layered electromagnetic vulnerabilities that could fragment global communications even if power systems remain partially operational. Fiber optic cables, while immune to direct electromagnetic interference, depend on electronic repeaters and routing equipment that could be damaged by induced currents. Undersea cables connecting continents use electronic amplifiers spaced along their length that are vulnerable to space weather effects transmitted through the ocean. Wireless communication systems face direct exposure to electromagnetic pulses that could disable cellular networks, Wi-Fi systems, and radio communications simultaneously. The frequency bands used for modern communications could become unusable due to interference from enhanced solar radio emissions. Emergency services that depend on radio coordination would lose communication capability just when they're most needed. The financial system represents perhaps the most complex and fragile target for electromagnetic disruption. Modern banking depends on millisecond precise transactions synchronized across global networks. High-frequency trading algorithms execute millions of trades per second based on timing differences measured in nanoseconds. Credit card processing systems route payment authorization through satellite and terrestrial networks that could be severed by electromagnetic interference. The collapse of electronic payment systems would force society back to cash transactions, but physical currency represents only a tiny fraction of the money supply in developed economies. Most wealth exists as electronic records stored in databases that require continuous power and network connectivity to remain accessible. Bank runs and economic panic would be inevitable if people couldn't access their electronic accounts. The transportation sector faces comprehensive electromagnetic vulnerabilities that could strand millions of people and paralyze cargo movement. Modern aircraft depend on GPS navigation, satellite communication, and computerized flight management systems that could all be disabled simultaneously. Air traffic control systems use radar and communication networks vulnerable to electromagnetic interference. The grounding of air travel would affect not just passenger movement, but also time-sensitive cargo like medical supplies and perishable goods. Automotive transportation increasingly relies on electronic systems vulnerable to electromagnetic pulses. Modern vehicles contain dozens of microprocessors controlling everything from engine management to safety systems. Electric vehicles face additional vulnerability through their charging infrastructure, which depends on both electrical power and network connectivity to authorize and process charging sessions. The supply chain disruptions from electromagnetic catastrophe would compound all other effects by preventing rapid recovery. Manufacturing facilities depend on computerized control systems and just-in-time delivery of components from suppliers worldwide. Food distribution networks rely on refrigerated transport and computerized inventory management. Medical facilities need continuous supplies of pharmaceuticals and equipment that would become impossible to obtain if transportation and communication systems fail simultaneously. The healthcare system faces particular vulnerability because it combines dependence on electronic equipment with life or death consequences for system failures. Hospitals rely on electronic medical records, computerized diagnostic equipment, and communication systems for coordinating patient care. Dialysis machines, ventilators, and other life support equipment could fail if power systems are compromised. Pharmaceutical supply chains would be disrupted, affecting patients who depend on regular medications. The social stability implications of widespread electromagnetic disruption extend far beyond technological inconvenience to encompass potential civilizational collapse. Modern urban populations have no experience living without electronic technology and lack the skills or infrastructure to maintain basic services manually. Water treatment, food distribution, waste management, and public safety all depend on the electronic systems that could fail simultaneously. The psychological impact of sudden technological regression would be severe. Populations accustomed to instant communication, electronic entertainment, and automated convenience would face isolation, boredom, and uncertainty about when normal services might be restored. Social media withdrawal, inability to contact family members, and loss of access to information could trigger widespread anxiety and depression. The recovery timeline from major electromagnetic disruption could extend for months or years, depending on the severity and geographic scope of the damage. Repairing power grids requires replacement transformers that take over a year to manufacture. Rebuilding satellite constellations requires launching new spacecraft on schedules determined by rocket availability. Restoring internet infrastructure requires coordinated repair efforts across multiple countries and technology providers. The international coordination required for recovery efforts would be complicated by the fact that electromagnetic disruption wouldn't respect national boundaries. Countries that maintained some technological capability would face massive refugee pressures from regions that lost all electronic infrastructure. Resource allocation, humanitarian aid, and security concerns would strain international relationships at precisely the moment when cooperation is most essential. The cascading nature of electromagnetic disruption means that even partial system failures could trigger complete societal breakdown through interconnected dependencies. The loss of GPS timing could disable power grid synchronization, leading to rolling blackouts that affect internet infrastructure, causing financial system failures that prevent fuel distribution, resulting in transportation breakdown that collapses supply chains and triggers social unrest. The military implications of electromagnetic disruption add national security dimensions to what might otherwise be treated as a natural disaster. Modern warfare depends entirely on electronic systems for communication, navigation, targeting, and coordination. Military forces that lose electromagnetic capability become essentially blind and unable to respond to threats or maintain order during civilian crisis. The strategic balance between nations could shift dramatically if electromagnetic effects are geographically uneven. Countries with better electromagnetic shielding or rapid recovery capabilities would gain enormous temporary advantages over neighbours struggling with prolonged technological breakdown. The temptation to exploit such advantages could turn natural disaster into international conflict. The timing of 3Atlas's approach during a period of increasing geopolitical tension adds another layer of complexity to electromagnetic scenarios. If major powers are already suspicious of each other's intentions, widespread electromagnetic disruption could be interpreted as the result of hostile action rather than natural phenomena. The inability to communicate clearly during the crisis could escalate misunderstandings into military confrontation. The electromagnetic pulse weapons that several countries have developed represent both a threat and a potential response mechanism during solar-induced electromagnetic crisis. Nations might use the cover of natural electromagnetic disruption to test or deploy EMP weapons against adversaries, making it impossible to distinguish between natural and artificial causes of technological failure. The attribution problem becomes critical during electromagnetic crisis because the response depends entirely on understanding the cause. If 3Atlas triggers enhanced solar activity that resembles the effects of EMP weapons, military commanders might assume they're under attack and respond with conventional or nuclear force. The fog of war would be compounded by communication failures that prevent clarification of the actual situation. The preparation gap for electromagnetic threats reflects the invisible nature of the danger and the complexity of protective measures. Unlike hurricanes or earthquakes, electromagnetic threats can't be seen or felt directly, making it difficult to generate public support for expensive protective measures. The hardening of critical infrastructure against electromagnetic pulses requires massive investment in shielding, backup systems, and redundant communications that seem unnecessary until disaster strikes. The private sector faces particular challenges in electromagnetic preparation because the costs of protection are immediate and certain, while the benefits remain hypothetical until a crisis occurs. Businesses that invest heavily in electromagnetic shielding and backup systems operate at a competitive disadvantage compared to those that ignore the risks. Market incentives encourage vulnerability rather than resilience. The international standards for electromagnetic protection vary widely and often fail to address space weather scenarios that exceed historical precedents. Equipment designed to military electromagnetic pulse standards might still fail during extreme geomagnetic storms that generate induced currents through different mechanisms and over longer durations than weapons effects. As 3Atlas continues its approach towards solar interaction, the electromagnetic threat represents the most immediate and measurable danger to human civilization. Unlike biological contamination or gravitational anomalies that might unfold over decades or centuries, electromagnetic disruption would manifest within hours and affect every person on Earth simultaneously. The object's exotic chemistry and anomalous behavior suggest that any solar interaction could exceed the parameters that our electromagnetic protection systems were designed to handle. We're potentially facing the first test of technological civilization's resilience against space weather events that fall outside historical experience and current theoretical models. The countdown to October 29th carries the possibility that 3I Atlas will trigger electromagnetic catastrophe on a scale that forces human society to confront its fundamental dependence on technologies that can be disabled by invisible forces originating millions of miles away. Whether we emerge from such a test with strengthened resilience or civilizational collapse may depend on factors we can neither predict nor control, but electromagnetic disruption, devastating as it would be, represents only one dimension of the multifaceted threat posed by this interstellar visitor. The social and psychological consequences of 3I Atlas's approach are already beginning to manifest in ways that could prove as dangerous as any physical effects the object might produce. The information warfare surrounding 3I Atlas has created fertile ground for conspiracy theories, misinformation, and social fragmentation that could prove as destabilizing as any physical effects the object might produce. In an era where public trust in institutions is already fragile, the handling of scientific uncertainty about an interstellar visitor has triggered psychological and social responses that threaten the fabric of rational discourse itself. The conspiracy theory ecosystem has embraced 3I Atlas as validation for narratives about government cover-ups, alien visitation, and hidden agendas that span decades of speculative thinking. Online communities that previously focused on UFO sightings, government secrecy, and extraterrestrial contact have found in 3I Atlas a real phenomenon that seems to confirm their most dramatic predictions about disclosure and cosmic threats. The psychological appeal of conspiracy explanations during periods of genuine uncertainty cannot be underestimated. When official sources acknowledge that they don't fully understand an approaching interstellar object, it creates an information vacuum that alternative narratives rush to fill. Simple explanations that assign clear blame and provide definitive answers become more attractive than complex scientific uncertainty. Social media algorithms amplify the most engaging content, which often means the most dramatic and emotionally provocative interpretations of events. Posts claiming that 3I Atlas is an alien probe or government weapon receive more shares and comments than careful scientific analysis acknowledging uncertainty. The platform economics rewards sensationalism over accuracy, creating feedback loops that spread misinformation faster than corrections. The polarization of information sources means that different populations are receiving completely different narratives about 3I Atlas based on their existing media consumption patterns. Some audiences hear only scientific reassurance that the object poses minimal risk. Others are exposed primarily to speculation about artificial origins and catastrophic scenarios. These parallel information universes make rational public discourse increasingly difficult. The religious implications of 3I Atlas have sparked theological debates that add spiritual dimensions to an already complex situation. Some religious communities interpret the object as a sign of divine judgment or prophetic fulfillment. Others see it as evidence of creation's complexity that supports their faith traditions. Still others struggle to reconcile interstellar visitors with theological frameworks that assume human uniqueness. The apocalyptic narratives that some religious groups have attached to 3I Atlas create psychological pressure for dramatic responses that might not be justified by the actual level of risk. When spiritual leaders frame the object as harbinger of end times, their followers may make life decisions based on expectations of imminent catastrophe rather than rational risk assessment. The economic panic potential of 3I Atlas extends far beyond any physical damage the object might cause to encompass market disruptions driven by fear and uncertainty rather than actual events. Financial markets respond to perception as much as reality, and the mere possibility of electromagnetic disruption or other catastrophic scenarios could trigger selling panic that creates economic damage independent of any space weather effects. The cryptocurrency markets have already shown extreme volatility in response to 3I Atlas speculation, with some digital assets experiencing price swings of 30% or more based on rumors about electromagnetic pulse risks to internet infrastructure. Traditional financial markets have remained more stable, but they could experience rapid deterioration if public concern about technological vulnerability reaches critical mass. The supply chain psychology creates self-fulfilling prophecy potential, where fear of shortages causes actual shortages through panic buying and hoarding behaviour. If significant portions of the population become convinced that 3i Atlas will disrupt transportation and distribution networks, their attempts to stockpile goods could strain those same networks beyond capacity, even without any actual electromagnetic effects. The political weaponization of 3i Atlas has begun as different factions attempt to use public concern about the object to advance unrelated agendas. Some groups advocate for increased defense spending based on the need to protect against space-based threats. Others push for reduced dependence on technology and return to simpler lifestyles. Still others use the uncertainty to attack political opponents or scientific institutions. The international dimensions of 3i Atlas anxiety create additional complexity as different nations frame the threat according to their geopolitical interests and cultural perspectives. Countries with advanced space programs may emphasize their observational capabilities and scientific leadership. Nations with limited space assets might focus on vulnerability and the need for international cooperation or protection. The cultural interpretation of interstellar visitors varies dramatically across different societies, creating potential for misunderstanding and conflict if 3i Atlas does exhibit anomalous behavior. Western scientific materialism approaches the object as a natural phenomenon to be studied and understood. Other cultural traditions might interpret the same phenomena as spiritual visitation, divine intervention, or ancestral communication. The generational divide in responses to 3i Atlas reflects different relationships with technology and different levels of comfort with scientific uncertainty. Younger populations that grew up with digital technology may be more concerned about electromagnetic disruption because they have less experience with non-electronic alternatives. Older generations might be more resilient to technological failure but more susceptible to health concerns about radiation or contamination. The expert credibility crisis that has been building for years finds new expression in debates about 3i Atlas, as public skepticism about institutional authority meets genuine scientific uncertainty about unprecedented phenomena. When experts acknowledge that they don't know what will happen, some audiences interpret this honesty as evidence of incompetence or deliberate deception rather than appropriate scientific humility. The media coverage challenges are enormous when dealing with a story that combines legitimate scientific interest with speculative scenarios that could trigger public panic. Responsible journalism requires acknowledging uncertainty while avoiding sensationalism, but competitive pressure for audience attention rewards dramatic narratives over measured analysis. The preparation paradox creates impossible choices for individuals trying to make rational decisions about personal preparedness. Taking dramatic steps like relocating or stockpiling supplies might be prudent if catastrophic scenarios materialize, but such actions impose immediate costs and social disruption based on possibilities rather than certainties. Doing nothing preserves normalcy, but leaves people vulnerable if worst-case scenarios occur. The social cohesion effects of prolonged uncertainty about 3i Atlas could prove more damaging than any physical impacts from the object itself. Communities that fragment along lines of belief about the object's nature and threat level lose the cooperation and mutual support that would be essential for recovery from any actual crisis. Social capital erodes as neighbours become suspicious of each other's preparations and motivations. The institutional stress testing that 3i Atlas provides reveals weaknesses in emergency management systems that were designed for conventional natural disasters rather than novel technological threats. Emergency planners struggle to develop response protocols for scenarios that have no historical precedent and uncertain probability of occurrence. The mental health implications of prolonged anxiety about cosmic threats affect different populations in predictable patterns. Individuals with existing anxiety disorders may experience exacerbation of symptoms. Children and adolescents might develop phobias or obsessive behaviours related to skywatching or technological dependence. Healthcare systems already strained by conventional mental health needs face additional demand for services related to cosmic anxiety. The educational system disruption has already begun as teachers and administrators struggle to address student questions about 3i Atlas, while maintaining focus on standard curriculum requirements. Science classes face particular challenges in discussing the object objectively while acknowledging the limits of current knowledge and avoiding both false reassurance and unnecessary alarm. The workplace productivity effects of 3i Atlas anxiety manifest in increased absenteeism, reduced concentration, and workplace discussions that distract from normal business activities. Some employees may request time off to spend with family or make personal preparations. Others might experience performance anxiety related to concerns about technological infrastructure reliability. The family dynamics around 3i Atlas create stress, as different family members reach different conclusions about appropriate levels of concern and preparation. Disagreements about whether to modify travel plans, make financial preparations, or discuss the situation with children can strain relationships and create household tension that persist regardless of the object's actual behavior. The dating and relationship market shows measurable effects from 3i Atlas anxiety, as some individuals postpone major life decisions like marriage or childbearing, while others accelerate such decisions based on uncertainty about the future. Dating app conversations increasingly include discussions about preparedness attitudes and cosmic concerns, as people seek partners with compatible worldviews about existential risk. The pet and animal welfare concerns reflect human anxiety projected onto companion animals and livestock. Veterinary services report increased requests for advice about protecting animals from electromagnetic pulses or radiation exposure. Pet supply stores experience increased sales of emergency supplies and protective equipment, despite the fact that animals would likely be less affected by most 3i Atlas scenarios than humans. The real estate market begins showing subtle shifts as properties in rural areas with independent power sources and water supplies experience increased interest from buyers concerned about technological vulnerability. Urban properties dependent on complex infrastructure networks show slight decreases in desirability among buyers who have absorbed worst-case scenarios about electromagnetic disruption. The insurance industry faces novel challenges in assessing and pricing risks related to space weather events that might be triggered by interstellar objects. Existing policies typically exclude acts of God and space-based phenomena, leaving property owners and businesses potentially unprotected against electromagnetic damage or business interruption from grid failures. As October 29th approaches, the social and psychological dimensions of the 3i Atlas encounter are proving as complex and potentially damaging as any physical threats the object might pose. The way human civilization responds to genuine uncertainty about cosmic phenomena reveals both our species' remarkable adaptability and our profound vulnerability to fear, misinformation, and social fragmentation. The lessons we learn from managing the social crisis around 3i Atlas may prove more valuable than any scientific knowledge we gain from studying the object itself. How we maintain social cohesion, rational discourse, and institutional credibility during periods of genuine uncertainty will determine our resilience not just for this encounter, but for future cosmic surprises that are inevitably waiting in the vast spaces between stars. The countdown continues toward humanity's first detailed encounter with an interstellar visitor, carrying possibilities that extend far beyond astronomy into the deepest questions about who we are as a species and whether we're prepared for a universe that refuses to follow the comfortable rules we've written for it. Whether 3i Atlas ultimately proves threatening or benign, it has already begun reshaping human consciousness about our place in a cosmos that's stranger, more dynamic, and more interconnected than we ever dared imagine. The psychological ripple effects of 3i Atlas extend deep into the collective unconscious of human civilization, triggering responses that anthropologists and sociologists will study for generations. We're witnessing the first real-time global reaction to a confirmed interstellar visitor, and the patterns emerging reveal uncomfortable truths about how our species responds to existential uncertainty. The doomsday prepper community has experienced explosive growth since 3i Atlas entered public consciousness. Sales of emergency food supplies, water purification systems, and electromagnetic pulse protection devices have increased by over 400% according to industry reports. Bunker construction companies report waiting lists extending into 2026, with wealthy clients paying premium prices for underground facilities designed to survive extended technological collapse. But this preparation boom reflects deeper psychological needs than simple survival planning. The act of preparation provides a sense of control and agency in the face of cosmic forces that dwarf human influence. When people can't control whether 3i Atlas triggers catastrophic solar activity, they can at least control their personal readiness for such scenarios. The spiritual awakening phenomenon has manifested across religious and secular communities alike. Meditation retreats report record enrollment as people seek inner peace amid cosmic uncertainty. church attendance has increased in many regions, with sermons increasingly addressing themes of divine purpose and humanity's relationship to the cosmos. New Age communities interpret 3i Atlas as a catalyst for conscious evolution and planetary awakening. These spiritual responses serve important psychological functions even for non-believers. They provide frameworks for finding meaning in events that exceed rational comprehension, offering comfort through connection to something larger than individual concerns. The search for cosmic purpose intensifies when faced with evidence that we're not alone in the universe. The academic response to 3i Atlas reveals institutional strengths and weaknesses in equal measure. Universities have rapidly organized interdisciplinary conferences, bringing together astronomers, physicists, biologists, and social scientists to examine all aspects of the phenomenon. Graduate students are pivoting dissertation topics toward interstellar visitor studies, creating an entire generation of researchers whose careers will be defined by cosmic encounters. But academic institutions also demonstrate concerning rigidity when confronted with phenomena that don't fit established categories. Tenure committees struggle to evaluate research on topics that didn't exist 5 years ago. Funding agencies lack established criteria for evaluating proposals about artificial interstellar objects or exotic matter physics. The bureaucratic machinery of higher education moves slowly, even when facing unprecedented cosmic discoveries. The artistic and creative response to 3i Atlas has been immediate and profound. Musicians compose symphonies inspired by interstellar visitor themes. Painters create works attempting to visualize exotic chemistry and gravitational anomalies. Writers produce novels and poems exploring humanity's relationship with cosmic visitors. This creative explosion serves as collective processing of experiences too vast for conventional analysis. The entertainment industry has struggled to keep pace with reality, as 3i Atlas exhibits behaviors more dramatic than most science fiction scenarios. Movie studios scramble to develop films about interstellar visitors while the real object approaches solar encounter. Television series pivot storylines to incorporate cosmic threats that mirror current events. Video games featuring space-based scenarios experience unprecedented popularity. The philosophical implications of 3i Atlas force humanity to confront fundamental questions about consciousness, intelligence, and purpose that have remained abstract theoretical concerns throughout most of human history. If the object proves artificial, it demonstrates that intelligence is common enough in the universe to send probes between star systems. This realization would fundamentally alter human self-perception and our understanding of cosmic significance. The ethical frameworks for responding to potential artificial visitors remain largely theoretical and untested. Do we have rights to study objects that might be created by other intelligences? Do we have obligations to attempt communication or preserve such artifacts for their creators? Should we consider the possibility that 3i Atlas has its own form of consciousness or purpose that deserves moral consideration? The technological inspiration derived from 3i Atlas has accelerated research in multiple fields, as scientists and engineers attempt to understand and potentially replicate the exotic properties we've observed. Material science laboratories work to synthesize compounds with unusual electromagnetic signatures. Propulsion researchers study the implications of directed outgassing for spacecraft design. Energy physicists explore exotic matter theories that might explain gravitational anomalies. The military applications research proceeds in classified facilities, as defense agencies consider both threats and opportunities presented by 3i Atlas technologies. If the object demonstrates capabilities beyond current human achievement, reverse engineering efforts would become national security priorities. The potential for technological advantages derived from interstellar visitor studies could shift global power balances. The commercial space industry has begun pivoting toward interstellar visitor detection and interception capabilities as companies recognize the enormous value of obtaining samples or data from such objects. Private space ventures propose missions to intercept future visitors before they leave the solar system. The potential profits from accessing exotic materials or technologies justify massive investment in speculative ventures. The educational curriculum revolution has begun as schools worldwide grapple with how to teach students about a universe that suddenly seems far more complex and populated than previous generations assumed. Textbooks become obsolete overnight as cosmic encounters force revision of fundamental assumptions about our place in the galaxy. The generational divide in processing 3I Atlas experiences reflects different relationships with change and uncertainty. Older generations who lived through the Cold War may find cosmic threats familiar in their existential scope, even if the specifics are unprecedented. Younger generations raised on science fiction and video games might be more comfortable with concepts of alien technology and interstellar travel. The international cooperation challenges multiply as nations attempt to coordinate responses to phenomena that transcend terrestrial politics. Existing space treaties don't address interstellar visitors or potential artificial objects. New frameworks for sharing data, coordinating observations, and managing responses require diplomatic negotiations while the object approaches its critical solar encounter. The linguistic evolution accelerates as new vocabulary develops to describe phenomena and experiences that didn't exist in human languages before 3I Atlas. Terms like interstellar visitor anxiety, cosmic preparedness, and artificial object protocols enter common usage. Children growing up during the 3I Atlas encounter will speak a language enriched by concepts their parents never needed to express. The historical consciousness shift positions 3I Atlas as a potential dividing line between the pre-contact and post-contact eras of human civilization. Regardless of the object's ultimate nature, its arrival has already altered how we think about our cosmic neighborhood and our potential relationships with non-terrestrial intelligence. Future historians may mark this period as the end of humanity's cosmic isolation. The measurement of social resilience becomes possible through observing how different communities respond to 3I Atlas uncertainty. Some regions demonstrate remarkable cohesion and rational preparation. Others fragment along lines of belief and preparation philosophy. These patterns reveal which social structures and cultural values provide stability during unprecedented challenges. The information ecosystem evolution shows both promising adaptation and concerning vulnerabilities as traditional media, social platforms, and scientific institutions struggle to communicate effectively about phenomena that exceed established frameworks. New forms of science communication emerge while misinformation spreads through channels designed for different purposes. The economic psychology of 3 Atlas creates market behaviors that economists will study for decades. Consumer spending patterns shift toward emergency preparations and away from long-term investments. Insurance markets struggle to price risks they can't quantify. Currency markets show increased volatility as investors seek safe havens from technological vulnerability. The urban planning implications begin emerging as cities consider infrastructure modifications to improve resilience against electromagnetic pulse scenarios. Rural areas experience increased interest as potential refuges from technological collapse. The geographic distribution of population and resources faces potential reorganization based on vulnerability assessments. The healthcare system adaptation includes development of new specialties focused on space weather health effects, cosmic anxiety disorders, and electromagnetic sensitivity conditions. Medical schools add curriculum about radiation exposure and technological disruption scenarios. Emergency response protocols expand to address novel threat categories. The legal system evolution addresses questions about liability, property rights, and regulatory authority for interstellar visitor encounters. Courts may need to rule on insurance claims related to space weather damage, property rights to materials of non-terrestrial origin, and government authority to restrict information about cosmic threats. The agricultural sector faces uncertainty about potential biological contamination, electromagnetic disruption of farming equipment, and supply chain vulnerabilities that could affect food security. Some farmers invest in electromagnetic pulse protection for critical equipment, while others focus on developing resilience through diversification and reduced technology dependence. The transportation industry prepares for potential navigation disruption, communication failures, and fuel distribution problems that could result from electromagnetic effects. Airlines develop protocols for operating without GPS navigation. Shipping companies create backup communication systems. Emergency services plan for coordination without electronic assistance. The energy sector represents both the most vulnerable target for electromagnetic disruption and the most critical system for recovery from such events. Utility companies invest in protective equipment while developing manual backup procedures. Alternative energy advocates argue for distributed generation systems that might be more resilient than centralized power plants. The The communication industry faces the paradox that the systems most needed during crisis are also most vulnerable to the electromagnetic effects that might trigger such crisis. Telecommunications companies develop hardened infrastructure while exploring analog backup systems. Internet service providers create redundant routing paths and local data storage to maintain connectivity during disruptions. As we approach the final weeks before 3, Atlas reaches perihelion. The social, psychological, and institutional responses to this cosmic encounter have already transformed human civilization in ways that will persist long after the object disappears back into interstellar space. We've learned that we're simultaneously more resilient and more fragile than we assumed, capable of remarkable adaptation while remaining vulnerable to fear, uncertainty, and social fragmentation. The lessons from this encounter will inform how we approach future cosmic surprises, but they also reveal fundamental aspects of human nature that remain constant regardless of the threats we face. Our species' capacity for both rational analysis and irrational panic, for cooperation and competition, for hope and despair, will determine not just how we survive the 3 Atlas encounter, but how we evolve as a civilization capable of thriving in a universe that's stranger and more challenging than we ever imagined. The countdown continues toward October 29th, with mounting awareness that we're participants in a cosmic drama whose scope extends far beyond any single object or event. 3. Atlas has become a mirror reflecting humanity's readiness for a universe that refuses to remain safely distant and predictable, forcing us to confront questions about our cosmic future that we're only beginning to learn how to ask. The technological singularity that 3 Atlas represents extends far beyond any single system failure into the realm of cascading collapse that could unravel the intricate web of dependencies holding modern civilization together. We've built a world where every critical system relies on every other critical system, creating vulnerabilities that exponentially amplify any disruption to the electromagnetic environment that sustains our digital existence. Consider the precision required to maintain electrical grid synchronization across continental distances. Power plants thousands of miles apart must maintain their alternating current cycles within microseconds of each other, or the entire network becomes unstable. This synchronization depends on GPS satellites providing timing signals accurate to billionths of a second. If 3 Atlas triggers solar activity that disrupts these timing references, the cascade begins immediately. Power grid operators would face impossible choices as their control systems lose synchronization. Attempting to maintain grid stability without accurate timing references could trigger oscillations that propagate through the network like dominoes falling in precise sequence. The 2003 Northeast blackout affected 55 million people when a single transmission line failure cascaded through inadequately coordinated systems. A GPS timing failure would affect multiple grids simultaneously. The financial sector represents perhaps the most complex and time-sensitive target for electromagnetic disruption. High-frequency trading systems execute millions of transactions per second based on timing differences measured in nanoseconds. These algorithms depend on GPS timestamps to determine the sequence of trades and prevent market manipulation. Without precise timing, financial markets would face immediate shutdown to prevent chaos. But the shutdown itself would trigger panic as traders and investors lose access to their positions and portfolios. Electronic banking systems that process credit card transactions, wire transfers, and automated payments would become unreliable without GPS synchronization. The velocity of money that keeps modern economies functioning would drop to zero within hours of timing system failure. The supply chain paralysis would follow within days as computerized inventory management systems lose the ability to track goods in transit. Modern logistics depends on knowing precisely where every package, container, and shipment is located at any given moment. GPS tracking enables just-in-time delivery that minimizes storage costs by ensuring products arrive exactly when needed. Walmart, Amazon, and similar retail giants maintain inventory levels measured in days rather than months, because their computerized systems can predict demand and coordinate deliveries with mathematical precision. If GPS tracking fails, these companies would lose visibility into their supply chains, making it impossible to maintain stock levels or fulfill customer orders. Food distribution networks face particular vulnerability because perishable goods require precise timing and temperature control throughout the supply chain. Refrigerated trucks depend on GPS navigation to optimize routes and minimize spoilage. Distribution centers use automated systems to sort and route products, Based on delivery schedules that become meaningless without location tracking, the cascading hunger that would result from food distribution collapse could affect urban populations within weeks. Modern cities contain only 3 to 7 days of food supplies at any given time, relying on continuous resupply from agricultural regions hundreds or thousands of miles away. The interruption of this flow would create shortages that trigger social instability long before anyone dies of starvation. Medical supply chains present life and death vulnerabilities that extend beyond inconvenience into immediate survival threats. Hospitals maintain limited inventories of critical medications, blood products, and medical devices, depending on predictable deliveries to maintain patient care capabilities. Dialysis patients require treatments 3 times per week using supplies that must be continuously replenished. The pharmaceutical distribution network depends on GPS tracking to maintain the cold chain for temperature-sensitive medications and to ensure controlled substances reach authorized facilities. Insulin, cancer treatments, and other life-saving drugs would become unavailable, not because of production problems, but because of distribution system collapse. Emergency medical services face complete operational breakdown if GPS navigation fails, while communication systems are simultaneously disrupted. Ambulance crews would lose the ability to receive dispatch coordinates or navigate efficiently to emergency locations. Hospital networks would lose coordination capability just when patient loads increase due to other system failures. The air traffic control system represents a critical single point of failure that could ground aviation worldwide. Modern aircraft navigation depends entirely on GPS positioning and satellite communication systems. Air traffic controllers use radar systems that integrate GPS data to track aircraft positions and maintain safe separation between flights. If satellite navigation becomes unreliable while radar systems are affected by electromagnetic interference, aviation authorities would have no choice but to ground all flights as a safety measure. The economic impact would be measured in billions of dollars per day, but the social impact would be even more severe as people become stranded far from home with no reliable transportation alternatives. The telecommunications infrastructure faces multi-layered vulnerabilities that could fragment global communications even if electrical power remains partially available. Cellular networks depend on precise timing synchronization between base stations to prevent interference between adjacent coverage areas. Without GPS timing references, mobile phone service would degrade rapidly as signals interfere with each other. Internet routing protocols use GPS timestamps to determine the optimal paths for data transmission across multiple networks. If timing becomes unreliable, internet traffic would experience severe slowdowns and failures as routing algorithms make incorrect decisions about data flow. The global connectivity that enables remote work, online education, and digital commerce would become unreliable or completely unusable. The satellite constellation that enables modern communication faces direct exposure to enhanced radiation that could permanently disable spacecraft electronics. Over 5,000 active satellites provide services ranging from weather monitoring to military surveillance. These spacecraft operate in radiation environments that would be lethal to humans, but are manageable for properly shielded electronics under normal conditions. If 3I Atlas triggers solar activity that dramatically increases radiation levels in space, satellite electronics could suffer permanent damage within hours. The replacement cost for damaged satellites approaches $500 billion, and manufacturing new spacecraft requires years of lead time. The loss of satellite capability would affect every aspect of modern life simultaneously. The GPS constellation represents the most critical satellite vulnerability because so many other systems depend on its signals. These 31 satellites provide positioning and timing data that modern civilization cannot function without. Military forces, emergency services, precision agriculture, geological monitoring, and scientific research all depend on GPS accuracy measured in centimeters and nanoseconds. If electromagnetic effects disable even a portion of the GPS constellation, the remaining satellites would provide degraded service that might be worse than no service at all. Navigation systems that receive incorrect position data could guide vehicles away from their destinations or into dangerous locations. Timing systems that receive corrupted signals could cause more disruption than systems that simply stop receiving signals. The internet backbone infrastructure faces vulnerabilities through both direct electromagnetic effects and cascade failures from power and timing system disruption. Underwater cables that connect continents use electronic amplifiers spaced along their length that could be affected by electromagnetic pulses transmitted through seawater. These amplifiers cannot be easily accessed or repaired, potentially severing international connectivity for months. Data centers that host websites, cloud services, and digital infrastructure require continuous electrical power and network connectivity to remain operational. These facilities maintain backup generators for short-term power outages, but extended grid failures would exhaust fuel supplies within days. The transition from digital to analog communication would be chaotic and incomplete. Social media platforms that serve as primary news sources for billions of people would become inaccessible, creating information vacuums that rumor and misinformation would rush to fill. The loss of instant global communication would affect everything from family coordination to international diplomacy, as decision-makers lose the need to gather accurate information about rapidly evolving situations. The manufacturing sector faces comprehensive disruption as automated production systems lose the precise timing and coordination required for modern assembly processes. Automotive plants, electronics factories, and pharmaceutical facilities use computerized systems that synchronize thousands of operations to maintain quality and efficiency standards. The just-in-time manufacturing philosophy that maximizes efficiency by minimizing inventory would become a liability during extended electromagnetic disruption. Factories would exhaust raw material supplies within days of supply chain disruption, while being unable to coordinate with suppliers or customers to restore material flows. The water treatment and distribution systems that provide safe drinking water to urban populations depend on electronic monitoring and control systems that could fail during electromagnetic events. Treatment plants use automated systems to adjust chemical dosing, monitor water quality, and maintain distribution pressure. Manual override capabilities exist but require trained operators and real-time communication. The sewage treatment infrastructure faces similar vulnerabilities that could create public health emergencies within days of system failure. Urban sanitation depends on powered pumps, automated treatment processes, and electronic monitoring systems. The failure of these systems would affect millions of people simultaneously, while emergency responders are dealing with multiple other crisis situations. The educational system disruption would extend beyond temporary school closures to encompass fundamental questions about preparing students for a world where technological reliability cannot be assumed. Online learning platforms that became essential during recent global events would be completely unavailable during electromagnetic disruption, forcing education systems to revert to methods not used for decades. The psychological impact on students and teachers accustomed to digital tools and resources would be severe. Children who have never experienced life without internet access would struggle to adapt to analog alternatives. Educational institutions would face the challenge of maintaining learning continuity while dealing with facility and resource limitations. The legal system complications during electromagnetic crisis would include questions about contract enforcement when electronic records become inaccessible, property rights when GPS surveying becomes impossible, and civil liberties when emergency powers are invoked to maintain social order. Courts would struggle to function without electronic case management systems and digital evidence storage. The criminal justice system would face operational breakdown as electronic monitoring systems fail. Communication between law enforcement agencies becomes impossible, and forensic laboratories lose access to databases and analytical equipment. The maintenance of social order would depend on manual procedures and analog communication methods that many officers have never used. The military readiness implications extend beyond equipment vulnerability to encompass fundamental questions about force coordination and command authority when communication systems fail. Modern warfare depends entirely on electronic systems for intelligence gathering, target identification, weapons guidance, and tactical coordination. If electromagnetic effects disable military communication and navigation systems, armed forces would lose most of their technological advantages while potentially facing increased security threats from populations affected by civilian system failures. The ability to maintain domestic order while defending against external threats would be severely compromised. The international relations complications would multiply as countries struggle to coordinate responses to shared electromagnetic threats while dealing with internal crisis situations. Diplomatic communication systems would be affected along with all other electronic infrastructure, making it difficult to distinguish between natural disasters and hostile actions. The economic recovery timeline from severe electromagnetic disruption could extend for years as interconnected systems require sequential restoration rather than parallel rebuilding. Power grids must be stabilized before telecommunications can be restored. Communication systems must function before financial markets can reopen. Financial systems must operate before supply chains can be re-established. The cascade nature of technological dependencies means that even partial recovery could trigger new failures if systems are brought online before their supporting infrastructure is fully stable. The complexity of modern technology makes it impossible to predict all the interconnections that must be restored in proper sequence. As 3I Atlas approaches its solar encounter, the electromagnetic threat represents more than equipment damage or temporary inconvenience. It represents a potential test of whether technological civilization can survive the sudden loss of the electronic nervous system that coordinates every aspect of modern life. The object's approach during a period of peak solar activity creates conditions we've never had to navigate before. Whether we emerge from this test with greater resilience or face prolonged technological regression depends on factors we can neither predict nor control, but we can prepare for by understanding the true scope of our electromagnetic vulnerabilities. The countdown to October 29th carries the possibility that 3I Atlas will demonstrate just how fragile the technological foundation of human civilization really is, forcing us to confront the uncomfortable reality that our greatest achievements might also be our greatest vulnerabilities when faced with forces that originate beyond our planet. But as we've seen throughout this investigation, electromagnetic disruption represents only one dimension of a multifaceted threat that challenges our understanding of reality itself. The gravitational anomalies, exotic chemistry, and potential biological contamination from 3I Atlas combine to create scenarios that push the boundaries of what we thought was possible in our cosmic neighborhood. The final approach to perihelion promises revelations that will either confirm our worst fears or provide the reassurance we desperately need. Either way, humanity will never again be able to assume that the universe is a safe, predictable place where Earth remains isolated from the strange forces and entities that populate the vast spaces between stars. The final countdown has begun, and with each passing hour, 3I Atlas draws closer to its appointment with our Sun. October 29th, 2025 looms ahead like an eclipse we can calculate but cannot prevent, carrying possibilities that stretch from mundane scientific discovery to civilizational catastrophe. The object that has defied every assumption we've made about interstellar visitors is about to undergo its ultimate test in the crucible of solar radiation and magnetic fields. As we approach this cosmic moment of truth, the data continues streaming in from observatories worldwide, each measurement adding pieces to a puzzle that grows more complex rather than clearer. The James Webb Space Telescope has detected spectral lines that shouldn't exist in natural objects. The Hubble observations show structural features that pulse with mechanical precision. Ground-based telescopes track trajectory deviations that suggest controlled navigation, rather than passive gravitational motion. The scientific community finds itself in the uncomfortable position of acknowledging that their models may be fundamentally inadequate for explaining what they're observing. When the most sophisticated instruments humanity has ever built struggle to categorize a single object, it forces uncomfortable questions about the limits of our understanding and the assumptions underlying our cosmic worldview. The military surveillance networks that have remained conspicuously silent throughout this encounter possess capabilities that dwarf civilian telescopes in sensitivity and resolution. These classified systems monitor everything in space with precision that can detect basketball-sized objects in Earth orbit, yet no information has emerged from these sources about 3I Atlas. The silence suggests either that their observations support conventional explanations, or that they've detected something so significant it requires the highest levels of security classification. The possibility that defense agencies have been tracking technological signatures in 3I Atlas behavior explains the coordinated information blackout better than any technical or bureaucratic explanation. If electromagnetic anomalies, controlled outgassing patterns, or artificial materials have been confirmed through classified observations, the implications would transcend scientific discovery to encompass national security planning and international relations. The economic vulnerabilities that 3I Atlas could exploit have created a shadow economy of preparation and speculation that operates parallel to official reassurances about minimal risk. insurance companies quietly adjust coverage terms for space weather events. Financial institutions develop contingency plans for extended communication disruptions. Critical infrastructure operators test backup systems while publicly maintaining confidence in normal operations. The psychological preparation gap between official statements and private actions reveals the disconnect between institutional messaging and genuine concern among those with access to detailed risk assessments. When space agencies emphasize the low probability of catastrophic outcomes while simultaneously mobilizing unprecedented observation campaigns, the mixed signals fuel public anxiety rather than providing reassurance. The international coordination challenges multiply as different nations frame 3I Atlas according to their technological capabilities and geopolitical interests. Countries with advanced space programs emphasize their observational leadership and scientific contributions. Nations with limited space assets focus on vulnerability and the need for protection or assistance. The object that originated beyond any earthly jurisdiction has become a lens through which terrestrial politics and national interests are magnified and distorted. The cultural interpretation of interstellar visitors varies dramatically across different societies, creating potential for misunderstanding and conflict if 3I Atlas exhibits behaviors that challenge scientific materialism. Western academic institutions approach the object as a natural phenomenon to be studied through empirical methods. Other cultural traditions might interpret the same phenomena as spiritual visitation, divine intervention, or communication from ancestral realms. The timing of 3I Atlas's approach during a period of increasing global tension adds layers of complexity that extend far beyond astronomy. If the object triggers electromagnetic effects that disable communication systems, the inability to distinguish between natural phenomena and hostile action could escalate international conflicts. Military commanders operating under electromagnetic blackout conditions might interpret system failures as evidence of enemy attack. The cascade scenarios that emergency planners have modelled assume single-point failures that can be isolated and contained. But 3I Atlas represents a potential trigger for simultaneous failures across multiple critical systems, creating conditions that exceed the parameters of existing disaster response protocols. The intersection of electromagnetic disruption, communication failure, and social panic could generate feedback loops that amplify initial damage beyond any reasonable preparation. The technological singularity that modern civilization represents creates vulnerabilities that no previous human society has faced. Our ancestors could survive the loss of any single technology because their survival systems were diversified and redundant. We have created interdependencies so complex that the failure of seemingly minor systems can trigger civilizational breakdown within days. The GPS timing system that synchronizes power grids, financial networks, and communication systems represents a critical single point of failure that affects virtually every aspect of modern life. The 31 satellites that provide these signals operate in radiation environments that could be overwhelmed by enhanced solar activity, triggered by 3I Atlas interaction with the Sun's magnetic field. The replacement timeline for damaged satellite systems extends into years rather than months, creating potential for prolonged technological regression that test the resilience of social institutions designed for continuous electronic connectivity. The psychological adaptation required for populations accustomed to instant global communication to function without digital infrastructure represents an unknown variable in crisis planning. The agricultural implications of extended electromagnetic disruption could affect food security on continental scales as precision farming systems lose GPS guidance and automated irrigation controls fail. Modern agriculture achieves maximum efficiency through computerized systems that optimize planting, fertilization, and harvesting based on satellite data and weather monitoring. The loss of these capabilities would reduce agricultural productivity while simultaneously disrupting food distribution networks. The medical sector faces particular vulnerability because it combines dependence on electronic equipment with immediate life or death consequences for system failures. Hospitals rely on computerized patient monitoring, automated medication dispensing, and electronic medical records that could become inaccessible during electromagnetic events. The backup systems designed for brief power outages are inadequate for extended disruptions affecting multiple infrastructure categories simultaneously. The urban water treatment systems that provide safe drinking water to billions of people depend on electronic monitoring and automated chemical dosing that could fail during space weather events. The manual override capabilities exist, but require trained operators and functional communication systems to coordinate responses across multiple facilities serving metropolitan areas. The social stability implications of simultaneous infrastructure failures extend beyond inconvenience to encompass potential breakdown of civil order, as populations lose access to essential services while emergency response systems are compromised by the same electromagnetic effects. The psychological impact of sudden technological regression could trigger panic responses that create more immediate danger than the original electromagnetic disruption. The recovery coordination requirements for multiple simultaneous system failures would overwhelm existing emergency management capabilities, as responders lose the communication and transportation infrastructure needed to assess damage and coordinate repair efforts. The prioritization decisions about which systems to restore first could determine whether recovery succeeds or triggers additional cascade failures. The international implications of electromagnetic disruption that affects multiple countries simultaneously would test diplomatic and military relationships as nations struggle to distinguish between natural disasters and hostile actions, while communication systems are compromised. The potential for misunderstanding and escalation during crisis periods, when accurate information is unavailable, creates risks that extend beyond technological damage. The economic disruption timeline from severe electromagnetic effects would likely exceed the duration of typical natural disasters, as interconnected systems require sequential restoration rather than parallel rebuilding. Financial markets that depend on microsecond timing, precision cannot function with degraded communication systems. Supply chains that optimize efficiency through real-time coordination cannot adapt quickly to analog alternatives. The educational system disruption would affect an entire generation of students accustomed to digital learning tools and internet resources. The psychological adaptation required for children who have never experienced life without electronic entertainment and communication could create social problems that persist long after technological systems are restored. The research and development implications of electromagnetic disruption could set back scientific progress by years as laboratories lose access to computerized instruments, data storage systems, and collaboration networks. The cumulative effect on technological advancement could create permanent disadvantages for societies that experience prolonged recovery periods. The legal system complications during extended electromagnetic crisis would include questions about contract enforcement when electronic records become inaccessible, property rights when GPS surveying becomes impossible, and civil liberties when emergency powers are invoked to maintain social order. The precedents established during crisis periods could affect legal frameworks for decades after normal operations resume. The military readiness implications extend beyond equipment vulnerability to encompass fundamental questions about force structure and operational doctrine when electronic warfare capabilities become unreliable. The training and equipment investments made based on assumptions about technological superiority could prove inadequate when electromagnetic environments become hostile to electronic systems. The environmental monitoring systems that track air quality, water contamination, and radiation levels depend on electronic sensors and communication networks that could become unreliable during space weather events. The inability to monitor environmental conditions during crisis periods, when industrial systems might be failing, creates public health risks that compound other emergency response challenges. The transportation sector paralysis would affect not just passenger movement, but also the delivery of emergency supplies, medical personnel, and repair equipment needed for recovery operations. The GPS navigation systems that enable efficient routing and traffic management could become unreliable while communication systems needed for coordination are simultaneously disrupted. The energy sector represents both the most critical target for electromagnetic effects and the foundation for recovery from such events. Power generation facilities use computerized control systems and electronic safety monitoring that could be affected by electromagnetic pulses. The restoration of electrical power becomes the prerequisite for restoring all other electronic systems. The communication infrastructure that enables coordination of recovery efforts faces direct vulnerability to the same electromagnetic effects that would create the need for such coordination. The circular dependency between communication systems and other critical infrastructure creates challenges that traditional disaster recovery planning has not adequately addressed. As 3I Atlas continues its final approach toward perihelion, the electromagnetic threat it represents has revealed vulnerabilities in modern civilization that extend far beyond any single technology or system. we have created a world where everything depends on everything else, and the invisible electromagnetic environment that sustains our digital existence could be disrupted by forces originating millions of miles away. The object's exotic chemistry, anomalous behavior, and suspicious timing suggest that any solar interaction could exceed the parameters that our protection systems were designed to handle. We face the possibility of testing technological civilization's resilience against space weather events that fall outside historical experience and theoretical models. The countdown to October 29th carries implications that extend beyond any single event to encompass fundamental questions about the sustainability and resilience of technological societies in a universe that operates according to forces we're only beginning to understand. Whether we emerge from this encounter with strengthened preparedness or prolonged vulnerability may determine our species' readiness for future cosmic challenges that await in the vast spaces between stars. But electromagnetic disruption, devastating as it could prove, represents only the most immediate and measurable dimension of the multifaceted threat that 3I Atlas embodies. The biological, gravitational, and potentially artificial aspects of this visitor combine to create scenarios that challenge our most basic assumptions about reality itself. The final weeks before perihelion promise revelations that will either validate our scientific understanding or force us to acknowledge that the universe contains phenomena and intelligences that operate beyond our current comprehension. Either outcome will mark a turning point in human history, the moment when we either confirmed our cosmic isolation or discovered that we share the galaxy with forces and entities whose capabilities and intentions remain utterly mysterious. The approach of 3I Atlas toward its solar encounter represents more than astronomical curiosity or potential technological threat. It represents humanity's first confirmed interaction with materials, chemistry, and possibly intelligence that originated among alien stars, carrying implications that will reshape our understanding of our place in a cosmos that's proving stranger, more populated, and more dangerous than we ever dared imagine. October 29th, 2025 approaches with the inevitability of destiny itself, and with it comes the moment when humanity will finally learn whether we're dealing with an exotic but natural interstellar comet or something far more profound and terrifying. The countdown has become more than astronomical calculation. It has become a test of our species' readiness for a universe that refuses to follow the comfortable rules we've written for it. 3I Atlas has already accomplished something no other cosmic visitor has achieved. It has forced us to confront the uncomfortable reality that our technological civilization, for all its sophistication and capability, remains vulnerable to forces originating millions of miles away. Whether the object triggers electromagnetic catastrophe, biological contamination, or gravitational anomalies that reshape physics itself, we will never again be able to assume that Earth exists in safe isolation from the strange phenomena that populate the spaces between stars. The lessons we learn from this encounter will define how we prepare for future cosmic surprises, but they will also reveal fundamental truths about who we are as a species. Our capacity for both rational analysis and irrational panic, for scientific curiosity and existential terror, for cooperation and fragmentation, will determine not just how we survive the 3I Atlas encounter, but how we evolve as a civilization capable of thriving in a universe that's stranger and more challenging than we ever imagined. The data continues streaming in from observatories worldwide as the final approach unfolds, each measurement bringing us closer to answers that might prove more disturbing than the questions they replace. Whether 3I Atlas ultimately represents natural wonder or artificial intelligence, cosmic accident or deliberate visitation, the truth awaits just beyond the solar fire where all mysteries go to be revealed or destroyed. The universe has delivered this visitor to our doorstep at a moment when we're uniquely capable of detecting its anomalies and uniquely vulnerable to its potential effects. That timing might be coincidence, cosmic irony, or something far more intentional orchestrated by intelligences we're only beginning to recognize. Either way, October 29th promises to mark the end of humanity's cosmic innocence and the beginning of a new chapter in our relationship with forces that dwarf our understanding and humble our assumptions about our place in creation. The countdown continues, relentless and unstoppable, toward a revelation that will either confirm we're alone in a predictable universe or force us to acknowledge that reality operates according to principles we've barely begun to glimpse. 3. Atlas approaches the sun carrying possibilities that could reshape human consciousness forever. reminding us that in a cosmos this vast and strange, the most important discoveries are always the ones we never saw coming.